I'm changing the activity because I don't have enough persons in the class.
Good afternoon, all.
Good afternoon. Can they see the board? If I can see the board.
Yes.
Slightly.
Slightly?
Yes, slightly.
Oh, I guess that's slightly.
Yeah. I can't make out exactly what's there.
I can't see.
So it's not so clear.
It's not clear.
That's all we have. That's why you're ready. You have to go to the polygon. So from next month,
So from the, they have to. Okay. All right.
That was not designed.
Oh, so this was not designed for this purpose.
This time.
All right. So we have a little problem with this person zooming in because I know that you guys should have your sites. What's the issue there? Good afternoon. Are you hearing me?
What's the question?
I'm saying that we're having some problems with the Zoom, and that's one of the reasons why we're starting so late also, because the process of setting up and getting everything ready. So you're supposed to be using a Polycam, and you guys are supposed to go to your site so you can log in there. So I'm trying to figure out what is the issue, why that is not happening with you guys. I'm not hearing you. Put your microphone on.
It just takes a little while to get from work to get home and then sign in. That's all for me.
Okay. So
Same here.
get to the site.
We are not at site because we are home. I'm home. Actually, we are actually home. Each person is at their own home. So you have to leave work and then get home and try to sign in. Because we are not all at one location.
No, that's not the thing, because they should have a site, right? All right, let me know somebody to explain a little bit better for you, because I'm sure that he has the information.
Oh, hello, good day. There should be a UE office or UE site in the various islands, and they have what is called a Polycom system. So when you go to the UE class, they would be using faster internet connection and a better camera system, so that you'll be able to see what is on the board.
Mm-hmm.
We have a high resolution camera that we can see the board, but it's not connected to the ordinary Zoom. Zoom is a cheap alternative that we allow the students to use for small classes. But when you want to be able to view the board and have proper classes, we would need to go to or to group at the various UV sites where they have a high-speed connection between each other. You understand me? So,
Yeah, I understand.
let me just ask, do you normally go to the UV site for other classes?
Yeah.
Yes, we do.
Good.
But
Go on.
yes, I was saying the reason why we are at home because the sign time, I believe there are classes who are using the facilities, which is the time we use right now from 3 to 8, right?
Mhm.
So I guess the resources are unavailable for us. That's why we are logging in at home at our personal location.
Okay, I understand. No, I do not think that is what is happening with the math. Because with math, we were told that the students would be using the Polycom system at the UV office. Good, because with math, the lecturer at this site at Mona, she's supposed to use the board.
You're supposed to be doing activities.
And activities as a group, so you have to come together at a UV site. So just contact the UV site in the various islands. So that
But I don't think you're understanding. Sorry, not to cut you short. What happened is that we had a situation where our timetable specifically tells us that the mathematics class, this class, the math course, we cannot be at the UV site. We are already at the UV site on Mondays and Wednesdays. On Tuesdays and Fridays, we stay home because there are other classes scheduled at the UV site at that present moment whilst we're having math. So we couldn't get any, the days we're having the classes, other classes like the English special and the IT specials are already taking place. So that is why our course is at home, and the same thing will be happening in the second session as well. So we have to be at home basically.
Okay, so the problem is that this is not my understanding, and I'm sure that you understand the nature of math. It's a little bit different. I guess you understand that. And because of the nature of the subject, I would need to use the board. I hope you understand that. Because I can't explain everything for you to get. Some of you are visual learners, so I need to be writing on the board. And not only that, because also the nature of the subject, again, I would want you to be able to work in groups. Are you understanding that? So for example, today, for a class like today, if you were on the Polycam now, I would be able to get you to do your activities. So we could be making our pieces and exploring how we can use them in different groups. I know that in one country, I think it's Dominica, there's only one person in Dominica. But I could liaise on with somebody from Mona to communicate via WhatsApp. But in a class like this, I feel a little bit crippled because I can't communicate with you. I cannot manage my class as effectively as I would want to. Is that clear? And I'm sure you understand why, right? So that's yes?
Till we understand.
Yes. So I don't know what is going to happen. I need to probably, I am going
to miss
probably the coordinator,
the administrator
here, and to see what she can do to kind of rectify the problem a little bit. But for now, this is what we have to work with. Now, so this is a challenge too. Even the activities that are brought, introductory activities that are brought for today, I can't even do it because persons are all over the place. Now, the activities on the board, I don't know if you can see it any better now. Is it any clearer? So that's a challenge too, and it's a challenge too in getting the class started because persons are zooming in from all over the place. Now, as was explained earlier, this is for small, like this Zoom thing is for small classes. This class has 14 students. So it is not the most ideal for the number of students and the nature of the subject. Is it clear? I know it's not your fault per se, but it's something that needs to be done, okay? Can't see the board still? No. Can't see the. Yes,
I
Donna.
can.
Can you just read what's up on the board first? Man, that's the only reason, that's the easiest way to go out with it.
But I will always need to write on the board. That's a problem. In the last class, they were able to see the board, so I don't understand what is happening now. Why they can't see the board?
What's the word after use?
Use 8 exactly 8 times to make 1,000. That's what it's on. Use 8 exactly 8 times to make 1,000. The last one comes to the board.
I can see the board. It's just that it's not a very.
It's a different camera. Exchange.
You can try. You'll have to work out that stuff.
I'm trying to get it sorted. Give me a minute, okay? So the question is, you can work on it in the meantime. Use 8 exactly 8 times to make 1,000. And it means that you can add, subtract, divide, whatever. At the end of the day, your result should be at 1,000. You should have 8 8s. Is it clear?
It's clear.
Right now you're recording, she's recording. And the book disconnect is reconfigure it. Recording is on. So like you would have had to have done it before because we have to restart it. So, for sure, they have to, the coordinator have to organize it. So that just
It can't be done in this class. This class cannot be done like this. I use a board and I have to write math. I have to write on the board.
and they have to do group work.
And they have to do group work. So it's not like some things they will just sit down together to do.
The other possibility probably is somebody saying if at the various sites the time is already booked for other classes.
I don't know, the coordinator because look here, the nature of the course, there's no way in the nature of a math course. If you want a certain quality, you estimates have to be
Somewhere together.
somewhere together. They cannot be at home because now home I would be able to see what they're doing at home. When they're doing activities, when I get Any luck so far? Any solution so far? No, still working? Okay, that's fine.
I have one.
You have something? Tasha?
Yeah.
All right, so we'll
Yeah.
just give the others some more time, okay?
Oh, okay.
Okay, so you're on the WhatsApp group? What's it, I mean, it doesn't matter because that's been added in one. Okay, so did you get any invitation from me? You're on WhatsApp, right?
I have something too.
No, so you only need to talk, please. One of these should contain, and then it should contain possibilities. And other
Oh, okay. Most of them are advanced. I'm trying to time before. There's a way. We just have to learn it's possible to switch. So I'm going to this before. When I can take a 4 minutes for that, we'll switch. Yes. So I'm ready.
Are we finished or still working? Jafar, are you done?
I got one.
Okay, and Tasha, no, you told me earlier you were finished. Sabina?
I got one.
What one?
Sabina, are you finished?
You could go ahead because I didn't get any.
I'm not hearing you.
I said I didn't get any.
Okay, Diane, are you there?
Yes, I got one.
Okay, all right. So I'm going to take all of this. Is it working? All right, so I'm going to take all the possible, so you have to listen when the board is not, because you're unable to see the board clearly, you have to kind of listen also on the right, okay? So we can test the solution. All right, what's the first one? Who wants to go first?
Okay. I have 888 plus 88
Plus 88.
plus 8 3 times. Plus 8 plus 8 plus 8.
Okay. Any other solution? And we are doing this because we're using nothing else.
I have one. I had what she had as well.
Okay. So yes.
Can I go ahead? I have in brackets 888 in brackets 888 take away 8. No, 888 take away 8 close bracket. No.
Sorry, I get you.
Yes, take away 8 close bracket plus 8
That's it. Tasha? Tasha, are you there? I think something is happening here. Tasha?
Hello?
Can you hear me?
Are you all hearing? If you could just unmute your mic and confirm. The lecturer is concerned as to whether or not you're hearing her.
We can hear
Can you hear
now.
me?
Okay. All right. Tasha, you want to talk?
Yes, can you hear me? Yes. So I had 888 take away 8 in brackets plus 8. Erase this. Erase everything you have there to the end. Yes. You have a plus sign there, right?
Yes.
Plus 8. Plus 8. Then a multiplication sign. open bracket, 8 plus 8.
Well, I guess you don't need this thing.
Take away 8.
Take away 8 where?
Yes. At the end, take away 8. Yeah.
Alright, let's see. So we're using exercises. So this wouldn't work now because this is gonna give me 0 if I'm using my bump dots. Oh,
No, no.
So because
8 plus 8. No, no, no. In the bracket, you have to have 8 plus 8.
here it should be what?
8 plus 8 there.
That's what I have.
Oh, I'm not seeing clearly.
So I have, let me go through. I have open bracket 8, minus 8, close bracket, plus
Plus
8,
yeah.
open bracket 8 plus 8, close bracket minus 8. See, Tasha?
Yeah.
But I don't agree because 8 plus 8 here is what?
16.
8 times 8. Alright, and that gives me how much? It's going to give me 800 plus 128 minus 8. So you get 880 for the first one. Yeah. Alright, so when you add this and this, what do you get? Remember, you have to have first because you follow the order from 1008. So, and then you subtract 8. Yeah. What do you get for the answer? 1,000. Oh, good. Yeah. All right. That was very good. Good job, Tasha. Any other solution? Yes, Jeff?
Thank you.
8 open bracket
8 open
8 times 8
times 8
plus 8 times 8 again. Close the bracket. Tasha, your mic.
Close the bracket.
Close the bracket. Minus 8.
You guys work. Minus 8.
The bracket must be. Hello?
Yes, I'm hearing you.
The bracket. 8 after the first open bracket, it's 8 times 8, no bracket. Remove the bracket in the middle. Remove the other bracket you have in the middle. No, leave the first one. The first bracket you had after.
Right. So it is 8 open bracket
8
times 8 plus. No
remove the second bracket that you just put there.
I did.
Remove the closed bracket after the third 8, sorry. Remove that bracket.
Okay.
Put plus 8 times 8 again. Now close the bracket. Minus 8.
Minus 8.
Minus 8.
Minus 8.
Minus 8. Minus 8.
All right, let's call 1.
No, 3 8. No, 3 8s. Minus 8 3 times.
All right, so we're going to take now. So we have to do 8 times 8 is 64.
64.
Plus 64.
Plus 64. That will give you 128.
Minus, this is what? Negative 8 and 8, 60, negative 24.
Negative 24.
Yes.
64 and 64 would give you 128.
128 times 8.
1 times 8 would give you 1,024. Minus 24.
Okay, let's give it
1,000.
All right, minus 24. Very good. You guys are doing very well. Any other solution? Alright, so should I give you one as a half? Let me see if I'm listening. And you can test it for me. Alright, so this is mine. For those of you who can't see, it's 8888 divided by 8.123. So it is 8888 divided 8 and 888.
It works.
All right, good job. So the idea is that if we learn how to manipulate numbers, how the number cells coming in here, and the same thing, you can encourage the students that look at this. This is also an example that sometimes in math, you don't only have one solution, there are different solutions. All right? Are we clear?
That's where you can
You can't use that because camera. I don't know.
So we can see them.
Yeah. No, they came in, so they're supposed to. That's what we just.
Yeah, we're just talking.
They were supposed to probably come at Louis office on Louis sides, but they're not using that. So nobody's on this.
Zoom can access that by that.
No. This is a polycom system. First in the lesson.
Right. Can you all see the PowerPoint? Can you all see the PowerPoint? No?
No, bring it down a bit.
Bring it down.
Bring down what? The camera?
Yeah. No, not down, up.
Screen.
Up.
Screen.
That's it?
Yes, that's good. That's fine.
All right. Good. Somebody saying something? Tasha, are you saying something?
I'm not here.
I'm seeing the PowerPoint now.
I'm not hearing you. Tasha, could you say that again for me?
Oh, I say it's much better. I can see now.
Okay, good. All right, so the idea is this now. The last class we're looking at the theory. So we're just quickly going to go through that to finish the theories, and then we're going to do our questioning. Look at questioning and how we ask good questions in the classroom, okay? Now we have this is the last theories that we're looking at. This is just something that we should have covered on Tuesday, but we didn't get a chance to. So we're looking at the Zoltan needs principles for math learning. Now you see the Dean's block or the base 10 template that you were supposed to make. Now Zoltan Dean is the person who created the Dean's block. Now he believes that the first stage, when you expose children to any form of manipulatives, you're supposed to allow them to have what is called free play. It's just for them to take the time to kind of explore them a little bit, look at them, see something new, look at them, see what they can do with it. You know, just even building blocks before you start to have them to play with them in a structured way. Just allow them to explore it a little bit first, okay? That's the first stage. When they give a child a manipulator, you're supposed to allow them some free play. Just some 15 minutes or 10 minutes, depending on the number of time you have, just to play around a bit, okay? Now, the next stage, so if you look here, you will have an idea of how your Dean's block is going to be used. The next stage is stage 2, learn to play by rules. So after they've played, or they've done the free play, then you can give them some rules, all right? We're calling this the flat, this the long, and this the unit, and this the units. Now, if you look at this, what do you notice about the flat versus the long versus the unit? What do you notice? There's a relationship between all the things.
The long is like more fun about the flat. So like flat has length and width, the long is just like a length.
All right. But sometimes it's a bit more, it's a bit more, sometimes it's a bit more specific, not that you're wrong.
In flat area. No.
Well, all of the area.
Okay, I'm thinking of like the line, sorry. What else? It's a part of it. And it's a part of it.
Takes 10 long.
All right, that's a very good. So he says that when you look at this, it takes 10 of this to make this. And what do you notice about the relation between the unit and the long? It takes 10 of the unit to make a long. So exactly. Now, when we have our base 10 blocks, that's how we're going to use them. So we'll have our 10 by 10, we'll have our longs, and we'll have our units. All right? So that's what we're going to do today. After you get a break, we're going to come back and we're going to cut out these manipulative and then explore how we can use them. So for this activity, I won't go into the activity until after we've made our Dean's blocks. Alright, so what we're going to do right now is we're going to quickly look at questioning. And what I want you to do is to choose a topic, any topic you want, and write down 3 questions that you think you would ask the students while they teach this topic. Any topic you're comfortable with, just choose a topic, and I want you to write down 3 questions that you think is necessary for you to ask the students while you teach the topic. Are we clear? Are we clear, Sabina?
You talk about the top 3 questions in the beginning where you first you're going to introduce the topic.
Doesn't matter where. Just write down 3 questions that you would have asked. Anything I would ask in teaching this topic. Any 3 questions. It doesn't matter if you're going to answer the front, the middle, or the end.
Okay.
Doesn't matter where it's
when you're introducing the lesson.
No, anywhere for the lesson. 3 questions you'd ask. Not yet. Finish. Finish working? All right, Jeff, you seem to be done. I'm going to start with you, and then I'm coming to Ricardo. Yes. Jeff, could you tell us your topic and the 3 questions you would have asked your students?
Relations, functions, and graphs.
Mm-hmm.
And I started by, I drew an arrow diagram. I gave a relation, and I was asking them what type of relation is this? And then I asked, is this relation also a function? And then identify the coordinates of the y-intercept.
All right. Yes, Ricardo?
Okay, my topic is...
Can you hear Ricardo? Good. Yes, go ahead.
The topic is place value. Question 1 is, what is the value of the 2 in 526? Second question, what is the face value of the underlying digit 6? Third question, what is the place value of 5?
All right. You want to go, Alisa?
Sure. I have circumference. I'm asking them, what do we mean by circumference? So what is the circumference of a circle? What is the relationship between radius and diameter? And what is the value of pi?
All right, I'm going to stop here a little bit, and then we should talk about these questions, and then I'll ask another 3 persons to go, okay? Now, if you notice, what do you note about the question that you gave, the question that you gave? What do you notice about them? Anything? All right, let's look at Alicia's 3 questions. The first question was what?
What do we mean by circumference?
What do we mean by circumference? What would you call it that? Is that a math fact, and will that cause the students to really think? It really is a math fact. And the thing about asking a lot of questions we call lower level questions is that we don't get our students to think. It's either they know this or they don't know it. Are you following that? So that is one example that it's an okay question, but it's not an excellent question. Are we following that? Next question.
What's the relationship between the radius and the diameter?
What is the relationship between the radius and the diameter? What do you think is that again? A math fact or really a thinking question? Sabina? What do you think?
There's an exact relationship, so I guess it's a math fact.
It's a math fact. All right. What's the next question, Alisa?
Value of pi.
What is the value of pi? Is that a math fact, or do you think that it will really cause the students to... All right. All right. Let's go to Ricardo. Let's examine Ricardo's question. What is the first one?
What is the value of 2 in 526?
What is the value of 2 in 526? Is that a math fact? Is that I know it or I don't know it, don't it? Next question.
What is the face value of the underlying digit 6?
What is the face value of the digit 6 that is underlined? All right. So you see the trend coming out now. So let's look at Jeffers' question. What was the first question again, Jeffer? Jeffer, can you hear me?
What type of relation is this?
All right. Is that a math fact or not? What type of relation is this? Is it that I know it or I don't know it? Would you think it would elicit a deep level of thinking?
It's not deep thinking. They have to do something to relation.
Is it that I know it or I know the elements that would make yes? So the point I'm making, I don't need to explore anymore. The point I'm making that is customary for us as teachers. We're asking facts in our classroom. We're not asking thinking questions. Are you getting the point I'm making? And if you should examine, so for the rest of for the other 3 for 3 other persons, I'm going to take only 1 question each. And let us look. It's customary. If we should do this experiment again, you'll notice that most of our questions, they're facts. They won't cause students to think because they don't know it or they just don't know it. If you know what I mean. It's not elicited any form of great deep thinking. All right, so I'm taking one from Ms. James.
My topic is coordinate geometry. And well, I choose the second question. How would you calculate the slope or the gradient of a straight line?
Is that a math fact or not? That's definitely a fact. If they don't know how to do it, they don't know how to do it. So if they know how to do it, they're just going to tell you how to. Okay, miss, you're going to do this. You're going to do it first. You do this, then you do that. But if they don't know, it's not like they can get the information from thinking. You understand the point I'm making? One more person.
I did the same topic.
Yes, so tell me.
And I asked them if the gradient of walking up a hill is the same as walking down the hill.
All right. So the thing about that question, it would have been, what's the gradient of? Is the gradient walking up a hill the same as gradient walking down a hill? So that question could have caused some thinking. If what? If you've given them the right, all the necessary information. Are you following that? Yes.
Okay. I would have what question?
Are you following that? So we want them to think. So I'm going to give you a little skeleton now. Yeah, you were saying something, Diana?
Go ahead, Miss.
Sure?
Yes, I'm sure. Okay. I mean, I would have done the body before, but I mean, that's very interesting. Is the gradient walking up the hill same as walking down the hill?
All right, so I think that is a good question, providing that you would have given the students the facts already, all right? Now, this experiment, this is something that I want you to walk in your classroom and be very conscious of. Am I asking the students on the facts question, and I'm not causing them to think? So I'm going to give you some possible questions that we want to ask in our classroom. You can fill in the missing parts. Oh, could I just use the board, right? Well, yeah.
I'll make sure it works on this. See if it works on my own.
Thank you. You made my job so much easier. All right, let's look at these questions. And I will. Huh? Did I do something wrong? I did something.
Probably blank.
Oh, the battery might have died. Can I tell you? Okay, we're coming. Once again, technology has failed. Okay. I'm so sorry, guys. Bear with me. Okay. What is this now? Oh. Right.
Oh no, just
Fine.
yeah.
We'll survive. Like, seriously? All right, sorry for the long wait. Can you see the PowerPoint? Yes? All right, so let's look at these questions here that we have to see how we can elicit some form of thinking. The first one we have, explain how you arrive at your solution to this question. That's a good question to answer for them to be able to rationalize their thinking. So sometimes it might see students are walking and they give you a solution, it's wrong. So you say, explain to me, you know? Sometimes by explaining, you don't have to tell them that, you know, you make a mistake right here. So they can figure it out. They can pick up just by trying and starting to explain. How can you be sure that? You know, you can't say that it's a different level or it's really getting them to step back and think. What would happen if? How do you know for sure that your answer is correct? Give an example. So when I give an example, so you cause them to think, to come up with something. Explain why. Tell me what is wrong with. So you never give you something, say again, you also give them to speak. What evidence supports your solution? How else might the problem be solved? What do you mean by the statement, blah, 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 blah? What makes da, 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 an example? What needs to be changed so that? All right. So basically, these are some of the questions. So we need to practice to use these types of questions in our classrooms to ensure that we get our students to think deeply, rationalize the solutions. All right. Any question? Don't agree? Remember, also you cannot agree with me. You don't have to agree. Diane, you have anything to add?
No, miss, no.
All right, so what do you think of the possible templates for questioning that I've given you? Do you think it's realistic?
Yes, it is based on good lesson planning.
It's based on the lesson plan. Good. So it's a general, it reminds us template, so it's a very general thing, but you have to take it and make it your own depending on the topic that you're teaching, okay? All right, so Jeffa, do you want to add anything?
No, that's okay.
All right, Sabina?
Yeah, I agree with you in terms of the questions, but You just have to take the time to listen to the answers and I guess follow up with that because you don't know how long it's going to take for them to explain and think about it. So.
Yeah, but that's what we want to. That's a good point you're making there. But that's one of the things that we want in our classroom. What is called discourse. We want them to talk because sometimes, as I explained, I think in Tuesday's class, sometimes the fastest way to pick up a misunderstanding or some gaps in how the thinking is through just them trying to explain what they've done. And the truth is, if they can explain to you what they understand or whatever, it is showing just how deep they understand whatever you're looking at. All right? That's a very good point, Sabina. Okay, good job. So I talked to Diane. Where is Tasha? I'm not seeing Tasha.
I'm here, right here.
Natasha, you're following me?
Yes, I am. Can you hear me?
Okay, I'm hearing you now. Do you want to add anything?
No, it's all clear. I quite agree with you totally. We need to have the children thinking based on the questions that we ask them. Quite agree with you.
All right. So basically, these things, they will be... All right, so I'm having a little bit of problems with the email. So let me... Ricardo, did you get email from me? Yes, so I'm having some problems. So this is what I want us to do. The files were on the WhatsApp group. If you're one of the persons who consistently receive email from me, please just forward it to everybody else, okay? Can I ask you to do that for me, please? So by the end of today, at least by tomorrow, the PowerPoint presentations will be out for you to use, okay? And even this questioning template, you can have it to use. You send it by email or well, I still don't have someone not that from Saturday by email. Everything for this class, I don't mind listening because I have an email group for you. So just please come to the second. All right. Yes. So when we start by studying, we're going to look at type of understanding. Okay, so how do I get this up here?
Good job.
Can I tell you? Yes. All right. So we're going to look at types of knowledge. And types. All right. So we're looking at two things here. We're looking at types of knowledge and types of understanding. All right. So basically, I don't know if you've picked up on the types of knowledge so far. So basically, there are two types of knowledge. Anybody knows? Anyone? Yes?
Conceptual.
All right, so we have two types. We have procedural and what is called conceptual knowledge. And following that, we have two types of knowledge, conceptual knowledge and procedural knowledge. Right. Those words seem pretty self-explanatory, right? What do you think procedural knowledge is versus conceptual knowledge? And I want you to give me an example. Okay. Everybody, think it through. What do you think procedural knowledge is? And what do you think conceptual knowledge is? And I want you to give me an example. So I'm giving you thinking time. You don't have to tell me right now. Let me give you 5 minutes to think about it, okay? Oh, actually, good. Thank you. See, if I'm thinking, what Huh?
Yes, there's more control.
Yes, right. Finish? Over there. So the teaching is
Well, I did the primary one course, second and fourth.
oh, but it's the next because the next was going to be from grade 7 to 9. But the next block is from 10 to 13. And so that is Dr. Nelson. Is it Dr. Nelson? 10 to 13? I'm teaching that course too. But not no, but someone. So that is the course. That's what that is going on. Hearing, lecture, and all. No? Well, it's good for you to recapture because I'm sure even the questioning and stuff like that, learning. Yeah. All right. And who wants to go first? Understand Ricardo, so we did the last time. So let me see who I should start with this time. Tasha. So you guys tell me what you think procedural understanding is and conceptual understanding is, and then you're going to give me an example of each. You know, how would you explain to somebody who's never heard these terms before?
Okay, to me the term says it all, right?
Yes.
Procedural means that's the how are you going to do something, the method of learning of something, right? The procedures, knowing that okay, this is done that way, all right? For example, so I'm going to solve a problem this way, or this skill is being done that way.
Mm-hmm.
That's how I get it, huh?
Okay.
Conceptual means understanding the method. All right.
I'm not seeing a distinction between the two things that you explained, you know?
Okay.
Yes.
Like I was saying, are you hearing me?
I'm hearing you clearly, but I'm not.
Okay.
So I don't know if you want to tell me what the distinction is.
Okay. Procedural means the way of doing something, the method of doing something.
All right? The method of doing something in the procedure, yes? And the concept?
And conceptual means understanding that this method is done that way. Understanding the method. So there's a difference between doing and understanding. That's how I
all
get
right,
it. That's
so
what
you're saying.
Okay.
So give me an example of each now.
Okay, are you hearing me?
I'm hearing
you. Okay, for example, problem solving, right?
Mm-hmm. For which one?
let's say, well, I teach at the primary level, so it will be quite different. The content will be quite different.
It's fine. It doesn't matter. The same thing across.
Okay, for example, I'm teaching fractions, right? Maybe addition of fractions. So they will know, okay, my students will know this is the way, this is the method, this is the procedures of working out, solving a fraction problem. All right? And with the conceptual, meaning the facts that the operations, the facts that the child knows in order to understand to do this problem. All right? Are you getting me?
I'm getting you, but I'm not.
Okay. Let me repeat myself again.
There's some parts that
Let me repeat myself again. The conceptual, right? I'm talking about the problem solving. The child needs to understand, okay, that this is done that way. All right? Are you hearing me?
I'm past the definition.
Okay.
So we're at the example. So I'm not sure if I'm agreeing with you.
So the fractions, right?
I agree with it. Okay.
Conceptual. I'm explaining my example.
All right.
With the conceptual, the child or the child will know, okay, this is the facts. I'm going to recall the facts and operations that I have already know in order that will enable me to understand solving that problem. Are you getting me?
I'm getting you. All right, so I see what you're getting at, but you're not being very specific.
Clear.
Yes, I understand what you're trying to say.
You got me on the spot.
Yes, I know, I apologize. All right, who wants to go next? Diane?
What something like the addition, that is the concept. And it's not really
I don't know if I'm seeing everyone or what. Is there anybody on that I'm not using up? Because I'm just picking a person that I can actually see. All right, go Diane.
She was right with the procedure, like you have to make if the denominators are not the same, you have to make them the same. Do this, do that. She was correct. I'm guessing now the concept is something like addition. What can be used in many other places, you know, and are not particularly related to that alone. So addition is a concept.
Addition is a concept. All right, yes, Alyssa?
I don't...
Alyssa wants to say something.
What I'm thinking is that the conceptual knowledge would be like knowing what something is, whereas procedure would be knowing how to do it. So I'm thinking like your conceptual knowledge would be like definitions. Like, for example, if we're using fractions, like what's that fraction?
You're perfectly defined. I would say you give a perfect definition of the things. Yeah. But let me see the example now. How you would match it to an example.
So like with fractions, I would think your conceptual knowledge might be, know what is a fraction, identify the parts, that this is the numerator, this is the denominator, so on. And then for your procedural knowledge, that would involve things like knowing how to add fractions or how to multiply or divide them, like how to manipulate them. That's what I would think would be the procedure.
Okay, so let me try.
Yes.
Let me.
Dana
here. I'm not sure if is that ready. Well, let's say for example, you are looking for let's say we have the quadratic formula: x is equal to negative b plus or minus the square root of b squared minus 4ac all over 4a. For me, that would be procedure because they know it already. But identifying how did we come about to get the formula together will be conceptual. So how did the quadratic formula come together using the b and the k and bringing them together will basically be the conceptual aspect of it, where the students will understand how the quadratic formula actually came together.
All right.
So, and that would be an example.
Yes, good try. Very good try, Zana. Very good try.
Can I try?
Sure.
For me, procedural would be performing a task like measuring the perimeter of a square. And conceptual would be understanding and interpreting concepts, having a sense of something. So, for example, you would teach a child the square root, but you would want them to understand what is meant by the square root, or the area, what is meant by the area. Not just how to find it, but what exactly is the area.
Okay, very good try. So some of you are saying it, some of you have it, but you're not. I think it's a math thing. We're not very expressive and very verbose and wordy. So I get what you're trying to say, but we're not on the ball, 100%. All right, anybody else want to try?
Yeah,
Go, Sabina.
Oh, I was saying, okay. For example, if you're teaching a topic like break even, I would think that the concept is for the students to understand what is break even. Basically, the whole concept that is when you're not making a profit, neither you're making a loss. That's you learning the concept. That means your revenue is going to be equal to your cost. They will know about revenue, how to calculate revenue, how to calculate cost. This is just they would have known the concept. So break even is when revenue is equal to cost, or you're not making a profit, you're not making a loss. These are the concepts that they would have to know, and to calculate it, the procedure would be you're going to equate your revenue and your costs. If revenue is equal to cost, then you are breaking even. Okay. And if you're able to.
Very good try. Very, very good try.
Can I make a point?
Sure.
So, from my understanding is that you have to understand the conceptual first in order to do the procedure, right?
You don't have to, because a lot of our students know but they don't know the concepts. You don't have to.
I'm just assuming, I'm just asking.
No,
do we have
it was a question to me. Well, saying that the problem with our math is that our students understand the procedure, but not the concept. So no, you don't have to. But what we actually, the purpose for this course is to push us to teach them both procedure and the concept, okay? Are you clear? Are you clear, Tasha? All right.
Yes, I am.
All right, so McCarthy, do you want to tell us? Since you did the course already, so we can do the detail.
For me, conceptual knowledge is more of this is like asking question, what is it? It's more knowledge based. It's more.
But in terms of knowledge?
Yeah, but conceptual, I think it asks question, why? Why is this how it is, and I think procedure is more using that knowledge to as Lee said, performance oriented.
Yeah, where is that?
But unless you share it, right? So I just want to give example.
All right, give an example. Give the example. Give the example.
All right, for procedure, for example, you say that break the timetable. 5 times 5 is 25.
The timetable.
Let's say 5 times 5 is 25. Okay, conceptual knowledge now is illustration. When you times a number by a number, you're actually increasing that number.
Or 5 groups of 5.
You're using, let's say, 5 groups of 5. That's that number. You understand? So basically, you're telling them that use with this knowledge, without procedural knowledge, still can't able to get out.
Yes.
So the more telling them, give them understanding why they do it, how they do it, and
all right, good. Very good. All right, so my quick, so you use the timetable as one example. Excuse me. Air conditioner. It's not a good try. Probably got this one. Can I say this question? procedure. We talk about really what we call the word is algorithm. All right? Yeah. And we talk about a step-by-step process to a solution. All right? So we talk about procedure. We know the algorithm. All right? This is how we work it out. That's what algorithms are. And we know the step-by-step process that will give us the solution. All right? Are we following that? Yes. Is it clear, everybody? Yes. Tasha? I see something like this.
Yes, yes, please.
Like in the bros, like, not really.
I am.
Okay. All right, so conceptual knowledge is the idea behind the topic or subtopic. All right, so let me give you an example. When we talk about perimeter, our students, as we explained yesterday, we talked about it yesterday, not yesterday, Tuesday. Our students will get that, all right, to find the perimeter out of all the sides around it, and that is the procedure. I'm going to add, let's say it's a rectangle. I'm going to add the length, the width, and the width again. That is the procedure. They just know that they're going to add up these things. But the concept behind perimeter is what? The distance around the boundaries of the figure. So that's the concept. Is it clear? When we look at the timetable, it is wrong for us to say 2 1s 2, 2 2s 4. Yes, but what's the concept behind that? Are we following the idea? The concept is if I have 2 times 1, what does this mean? 2 groups of 1. So I have one group with 1 and another group with 1. And I put that together and I end up with 2. 2 times 2 actually means 2 groups of 2. So in this group, I would have 2, and in that group, I have 2. Altogether, I end up with 4. So this would give me 4, and this would give me 2. And we're seeing that. And each time, the whole idea of multiplying, each time we're adding, we're really adding, because look at this. We add there, and we added there. So the idea there is addition. Are we clear? Is it clear? No? Tasha, are you clear? Jeff, are you with me? Zana?
Yeah, I'm there.
All right, Miss James. Are you following what I'm saying? Do you know get the difference between the two things? And
yeah, I kind of got the difference before. Okay.
Yes, could you say it again, Anya?
I kind of got the difference from before, but yeah, I understand.
Okay. All right, so we're looking at the types of understanding. Do we know them, anybody? Yes, Anya, what are the types of understanding? There are 9 types of knowledge. What are the types? Richard Skem, he's in charge of understanding. He talks about understanding, types of understanding. Skem, S-K-E, S-K-E-M-E.
That's something I'm supposed to.
So, Anya, we're waiting. Or do you need some time?
I don't know the types of understanding. Let me check. I don't know.
You don't know? Okay, no, that's fine. Anybody? Diane, do you know? Diane, do you know the types of understanding?
No.
Okay, Jeffo, do you know? Jeffer, can you tell us? I'm not hearing you.
No, I don't. I cannot.
All right. So, do you know the types of understanding? Yes, there are 2 different things. They are aligned, but they're 2 different things. Understanding is different from knowledge. Thank you very much. I bet so. All right, let me go. All right. So the types of understanding, this is what we call instrumental understanding. And then we have relational understanding. Are we clear? We have two types, instrumental understanding, relational. Now, procedural understanding is linked to instrumental, procedural knowledge is linked to instrumental understanding, and conceptual knowledge is linked to relational. Instrumental understanding is knowing what to do. A relational understanding is knowing what to do, know what to do, and why. You see the link now? I see the link. So for procedural, for instrumental understanding, it is saying that you have procedural knowledge for you to have instrumental understanding. If you have instrumental understanding, it's because you have procedural knowledge. Is it clear? No. So if I know that, for example, perimeter, when I'm finding perimeter, all I know is that normally what Miss would do, she would add up all the sides. It's because my knowledge is limited to that. So I don't have I just know what to do in terms of finding a perimeter. I know how to do it, what to do. Mm-hmm. But for concept, I know that, all right, I'm adding up all the sides because perimeter is about the distance around the boundary. So you know what, so all right, I'm adding up the side because. You see the difference? Mm-hmm. And you see which one is a deeper understanding? Relational. And that's what we're aiming for them to know what I do and why. Yes, have a question?
Yeah. What is the difference between procedural knowledge and instrumental understanding?
There's no difference really. It's just that one is called knowledge and one is called understanding. Because certain kind of knowledge, it will give you a certain type. Because remember now, if I only have a procedural knowledge, it's going to limit me to just that kind of understanding. It's just that there's difference between the knowledge and the understanding. But that's why they're connected. One is just knowledge and one is just different one. But it's a type of knowledge that causes this type of understanding. Okay. Are we clear, everybody?
Yes, we are.
Yes, Jeffra? You saying something?
I was saying yes, we're clear.
Okay. Any questions so far?
No.
Okay, so what I'm going to do, I'm going to challenge you one more time to come up with an example, choose a topic, any topic, and I want you to tell me for that topic that you've chosen, what is the conceptual knowledge that you give to the students and what is the procedural knowledge? Is it clear? Good. That's not what you do? Alright, so guys, you can discuss via WhatsApp if you want. For those of you who are here, you can talk. But those of you who have zoomed in, you can discuss via WhatsApp to each other. I won't be taking part in that discussion, of course, but you can discuss and share your ideas if you feel like.
Challenge to always be here. Yes, and if I'm not here, Ricardo will do it. Good. Just for Mona, right?
They have to let Mona and then I'll tell this right for the ones right here. So to do Mona right, I'm going to tell you out. We have to write without keeping register. And it
might be a Zoom. It might be a Zoom.
Oh, there.
Zoom.
No, but what happened is that on the informal, more students, part of it have. Really? Yeah. I said, you have your scissors and your thumb. So right after you finish sharing, you're going to take a break. This. And roll it and put this and this. Oh, you need a register. No, I just want to be able to keep like tell us how to eat. Yeah. So I'll give it this, and you can just kind of probably find a place to get somewhere. I want to write down. Would you like to get some? I no, I didn't get that soft. I need to write the register. Would you like to get some? Okay, I think you should. I trust you. I trust you a little bit more. No, it doesn't matter if you're not here, then yes, that's what I'm doing. Right in the register, or she's up the candidate and she's a all right, and then you'll give it to me, and I'll keep it. This is everybody. And everybody's gonna say turn. I'm gonna use this person. Colleen. Is Colleen here? Okay, so I really have to start keeping a register because I need to give a call because everybody's not coming.
Should I put it in terms of location?
Yes. There is always one so okay, that's good. All right. Are we ready now to go? Who wants to start first? Sabina, you want to go first?
Not particularly, but since you call, I
want to know to go first. See,
what was that?
No, it's a democratic classroom system. I want to know you to go first.
It's okay.
Diane, you're going first. No more democratic classroom.
It's okay.
I am stuck since we started talking about fractions and the addition of the two fractions. Now, in the lower school, especially when you're adding two fractions with different denominators, sometimes you tell a child, make the denominators the same, multiply this and multiply that, and then you add, when the denominators bottom are the same, you add the numerator. Now that is procedural, but the concepts behind them, because if you follow that pattern for multiplication, where you have two fractions with different denominators, it wouldn't work. So therefore, when you are just teaching instructional things, it works only for one thing, and sometimes you cannot transfer it to something else. So there are concepts missing in that even addition then will be a concept, because how we treat when adding two numbers is different from what it means to multiply two numbers. So addition is a concept. The second thing is that we will have to deal with the concept of equivalent fractions, and we also will have to deal with all of that. So if you dealing with it, what it is relationally, then maybe you have to go into all of this. Why am I multiplying this denominator to make them both the same? Is because I'm creating equivalent fractions. why is it we have to make them the same for addition? You know, and if they understand that, you know, sometimes you see kids who don't understand what addition means and what multiplication means. When they're multiplying fractions, they are also creating LCMs and they're doing all of that. So that is, I don't know what I just said, but that is what I'm thinking.
That's funny. So you talked about fraction. So you're saying if I should add 1/2 plus 1/3. All right. Now the thing is this. When I do this, I'm really just doing algorithm notice. That's what you're saying, right? Right down?
Yes,
and whatever. I'm really just doing algorithm. And there's no deeper understanding than I know that I must draw a bar, find a number that's common between both denominator, put this number into this one and multiply up here, so we'll take the bar and add it. And we know that it's a very structured thing. We do this first, that second, that third. Are we clear? So this here is definitely instrumental understanding or just what? Procedural knowledge. But if I know that, I can write 1/2 another way. That's it. And I can write 1/3 another way. It's the same value represented with different fractional names. Agree? So this is me now understanding the concept. Understanding the concept that addition means to put together. That's the whole idea behind addition. I'm putting things together. And I'm understanding the whole idea of why I need something why I'm drawing this bar thing and find an LCM is because of this. There are two different. So what is there are two unit fractions. One belongs to the family of half, and this is the family of thirds. Because they're different, we need to do what is called renaming. Do you understand that idea? So when we rename, I'm looking for something to give both of these the same denominator. So I'm thinking of how else can I write a 1/2 to get it to be a common denominator? How else can I write 1/2 and 1/3 to ensure that both of them give me a common denominator? All right, so I know that 1/2 can be written as what? 3/6, that's the same as 1/2. It's the same amount, isn't it? I want to look at 1/3. How else can I write that? 2/6, and it's the same amount. This and this, same, and this and this. Oh, sorry. And this and this, same. Agree? So, that bar thing there is definitely procedural. Understanding what to do, some rationalizing, what I can rationalize. I need something that is the same amount as this one. Or it's going to write up. We can write it 2 4s, 3 6, 4 8. There's several ways we can write 1/2. Okay? Several ways we can write this 1 6. So it means that I understand what to do, but I'm also understanding what? Why I do it. Is it clear? Good job, Dan. Who wants to go next? So in this problem, what do you know? Several concepts, because the concept of addition must come out, and the concept of equivalence must come out. The same amount represented with different fractional names. Want to go?
Just a very simple one, just with simple multiplication. Let's say we wanted to say 15 times 8. And so, in general, we learn in school, you multiply your number on the ones line, and so you say 8 5s, you get 40, you put a 4 up there, you carry your remainder, you multiply 8 once 8 and 4, 12. But if I was just sitting here and somebody said to me 8 times 15, a simple way is you could break up the number, multiply the parts, and then put them back together.
That's one way.
So I would say 8 10s is 80, and 8 5s is 40, and do that in my head, and then I put them together. And I would get 120.
Very good. And even this is a lie that we tell the students. So I'm multiplying 15 times 8. But I really think this is 8 times, what is this?
1.
No?
10.
10.
Yeah.
8 times, so this is 80.
Yes.
And 8 times 5 is what? So even if we multiply 12 by 11, really this is 1 times what? 2. But this is 2, this is 1 times what? 10, which is, and this is what? 10 times 2, which is what? And this is 10 times 10, which is? So basically, this is the thing to know, when we expose them to even different algorithms, that's the next thing. We realize that they are able to they can have a deeper understanding. If we just having them 1 times 2 is 2, 1 times 1, this is not a 1. This is really a 10. So we really have to really pull them away from that. There's a bar thing that I like to show my students too. What is? So if you give us, that's the thing, when you plan a lesson for differential instructions, you have to use different method. So you show them one method, explore, when they explore different method, they have a wider understanding and deeper understanding. So I usually, this 12 can be 10 and 2, and this level can be 10 and 1. Same thing. This is 20, this is 100, this is 20, and that is 10. When you sum them, you get a total. So you break the numbers, and you can do for any number. Are you seeing the board, guys? No?
Yes.
Board?
Yes, we can.
You can?
Yes.
1, 2, 20.
Yes. Lower right hand box.
Lower right quadrant.
Take out the 0.
I think my brain working faster than my hand, or my hand working faster than my brain. One of those.
Yeah.
One of those. Huh?
Hands are working, nothing else.
Are you following that example, everybody? Zana? Zana?
Yes, I'm here.
Did you follow what I just wrote on the board?
But actually, my internet was working a bit slow, so I didn't get it.
Okay. So we're just, Alyssa gave an example of multiplication. She was saying that when we're multiplying, for example, 15 times 8, we would say 8 times 5, and we put down the 0 and carry the 4. 8, 1, 8 plus the 4 give us 120. You follow that, Zana? But we're saying that, and that would just be pure procedural. Agree? But when we look at the concept behind multiplication, so look at the concept is really 15 groups of 8. Are you following that?
Yeah, I am.
Or we are, because multiplication is commutative, it can be 8 groups of 15. Doesn't matter. Following that?
Yes, I am.
Good. And we look at some different method, different algorithm method that would give the students a deeper understanding. So we look at this box thing here, we call I think it's the error model. And then we look at the place value method. Can you see the board?
I am seeing the bubble, but I'm not seeing the place value at the bottom.
This is the one that we did. So we did 8 times 10, because this is really a 10. And we got this 80, so that's the place value. So when we're teaching it like this, the students have an understanding of the place value, the red was the height of place value. And then the 8 times the 5, which is the 40. Then we sum that. Now we look at this, which is also the place value model. 1 times 2, 2, 1 times, and this is really a 10. That gives me this 10 here.
Then I do the second times 2, which is a 20, and a 10 times 10, which is a 100. Then I find the sum. And this is also the place value model, understanding that in 12, I have a group of 10.
Excuse me.
Units, and I have one group of 10 and one unit. So 10 times 2 is still 20. 10, 10, 100. 10 times, 1 times 2 is 2, and 1 times 10 is 10. And
Excuse me.
Yes, Jennifer?
Can you lower the camera so we can see the board? Because we're seeing the top of the board.
Oh, is it better?
Too low. Go a little higher. And a little to your right.
Man, that's what
to your.
She wants to see the board. Okay. All right.
Thank you.
Better.
All right. Are you able to see everybody?
Yes, I can.
Any question? Tasha, you're in primary school. What do you think of these methods we just explored?
Yes, it's okay. I have used it before.
Good. All right. Who is next? The example? Not you? All right. Tasha, you want to go with your example? All right. So we have 2 more minutes of this. I'm taking a break because we need to do our manipulatives.
Okay. Well, I just have 2 small example. I use the topic parameter. All right.
I use the topic parameter already. Come on.
Oh, really?
Yes.
Okay. Well, you will have to. Okay, I'll just summarize it. Measuring the perimeter of a box, procedural, right?
What?
Measuring the perimeter of a box. Are you hearing me?
Of a box?
Yes. Yes. And
no, not a box. You can measure perimeter of a box.
You can.
Do the surface area of a box.
Tasha, think about it a little bit more. When you say measure the perimeter of a box, what do you mean?
I said the surface of a box. Can you hear me?
I'm hearing you.
I said, let me repeat myself again. Measuring the perimeter of a surface of a box. Can you hear me?
Surface of the box.
Yes, surface.
One of the surface of the box.
Surface of a side.
Can you hear me?
I'm hearing you, Tasha. I'm just trying to understand what you're saying.
Yes.
So go again. Tasha?
Are you hearing me?
Hearing you.
Okay, estimating the perimeter of the surface and justifying that. And so in order for you to solve this problem, you need to understand.
Okay. Tasha, 1 second. Where I'm not understanding you is when you say find the perimeter of the surface of the box or surfaces of the box. I'm not sure if I'm clear what you're saying there.
I said surface. Can you hear me?
One of the surface?
One.
But why would you use a box? Do you think a box is ideal then?
Yes. Or if you want, I can use a shape.
Okay.
All right.
I use something that is.
I'm just trying to make out a point.
Okay. But you see, you have to be like, so part of this course now is not only using something, but what is most appropriate for what you're teaching. And so I would say that if I'm going to teach perimeter, probably the box is not the most ideal. I don't know if you understand what the point I'm trying to make. No? Yes. Tasha, you understand what I'm saying?
I am, but
But because part of giving good instruction is choosing appropriate materials to use. So that's the point I'm trying to.
I can use the surface. The surface can be the shape of a rectangle or a square. Are you understanding what I'm trying to say?
You're saying now.
Right? And are you hearing me?
I'm hearing you. I'm thinking too. So I'm hearing you.
Okay, the point I'm trying to make is that, okay, whatever the question is, right? The child needs to understand the concept and operation for perimeter, how to solve this problem. Do you understand what I'm saying?
I understand what you're saying, but I'm still waiting.
The relation between the concept and the operation.
Mm-hmm.
All right?
Yes. All right, so anybody else have anything to add to what she's explaining? I shall just choose somebody to give their opinion. What she said? Yes. All right, Ingrid, you want to go? Okay. All right. Jeffrey, what do you think about what Tasha has been saying?
I used an example with perimeter, but I just used a rectangle, a normal shape, and I was thinking to.
Box, though?
No, I wouldn't use the box. I think the box would confuse the students because maybe I'll take cut off a face from the box instead and bring it to them instead of the whole box. But with mine was similar to Tasha using perimeter, and I would say the student needs to understand what is perimeter, which would be conceptual, and then we would give them a formula like length plus width plus length plus width, or 2 times length plus width. And I would say that would be procedural instrumental.
Okay, good. All right, so Tasha, the point I want to...
So basically, this was what I was trying to bring across.
Okay.
But when I say the box, I mean the surface of the box, not the entire box, but the surface. All right? So here we have the students identifying the surface of the box in order to calculate the perimeter.
Okay, yes, and you're not wrong. You're not wrong at that. That's the point I'm making. You're not wrong. But I'm trying to bring you to get where I am at in terms of the appropriateness of using the box versus probably a plain shape.
I think that have to do with the level that you are teaching to.
Okay.
I don't. Can I talk?
Because these are questions that I have formulated, especially teaching the primary level. Certain questions have been formulated using maybe the box as an example.
But the box is really a 3D. What I'm trying to say, the box. All right, Sabina, you can go ahead. Yes. You wanted to say something?
Yeah. I think by using a box to measure perimeter, just the surface of a box can be confusing for a student. If you want to use a box, I would have used maybe a storyline inside of the box. If maybe a mouse or something is walking inside of the box, what is the perimeter? Because they know that perimeter is the distance around. So how much space would they have to walk across and above? So what distance around can they walk? Maybe I would use inside of the box instead of the surface of the box as perimeter, because it can be confusing because they're trying to measure distance around something.
Okay, so the point I'm trying to, like, Tasha, I don't know how to put it across to you, but the point I'm trying to make is that even though we can use some material to teach something, it might not be the most appropriate. So, for example, when you think of a perimeter concept, you're thinking of a two-dimensional idea. That's the point I'm making. So when you bring a 3D object now, you're trying to link two things that should not be linked. Is it clear? I don't know how to explain it, but as I said before, part of this course is ensuring that we're choosing the most appropriate material to teach whatever we're teaching. So it's just like surface area or even net or volume. So if I'm using like, so for example, if I'm teaching perimeter, one of the things I was using, I would not even use even a rectangle or a square, or I just pick up a leaf from outside. That's the first thing. I'll just walk up, pick up a leaf outside, and I'll come and say, how would you find the perimeter of this? And I'll probably talk about what perimeter is. And I'll probably give them some strings and some rulers and something and say, go ahead and find the perimeter. So probably they could know that, all right, I'm going to put the string around the boundaries there and probably measure that distance I was taking up on my ruler. Now, if they're able to do this, once I've done that, then I wouldn't even, I would just put some shapes on the board and just say, find the perimeter. If you would understand the concept of perimeter, use that knowledge to solve the problem on the board. That's what I would have done. I wouldn't give them any regular, the shapes that they use in everyday math. Something kind of look more like a plain shape, like, you know, because we know that whatever in real life is really pretty. But so we're not focusing on semantics now. But really something that is flat, just add the perimeter of flat. Doesn't have to be a rectangle, a square, or triangle, anything like that. But are we on the same page, everybody? So a little bit more thinking, so that your concept is right, but in terms of the appropriateness of the box, give us a little bit more thinking from it, please, okay?
Yes. Yeah.
All right, so who wants to go next? All right, so I can take one more and then we get a break because we need to come back and start making our templates for our next part of the lesson, of course. All right, tell you what, I'll just give you a break and then we'll come back and do the templates. You have half an hour, so it is now 10 minutes after 4, you come back at what time, everybody? So we come back at 4:40 on the dot. If not, come back at 4:39. Huh? And so, answer your point, but my thing is I don't want to force people to sit for like for so long because you know the 2 hours of brain, like you know, so I'm using the whole neurological science to instruct the class, the brain not supposed to be the other 2 hours. So I need at least 20 to half an hour break to kind of get the difference. So that's what I'm thinking of, different state of mind. To sit for 5 hours is I'm going to stay open. For class, for learning. That's the point. I cannot talk to people. Yeah, that's what I'm saying. Yeah. I think for you, the course is this. What is? And then
so those who are what's the difference?
Right. I don't know. I'm not in charge. But the thing is this too, the nature of the math, because most of you the deans look and these things. If you're here, you're better able to follow than if you're trying to
So then those people will be at a disadvantage.
They are, definitely. Because sometimes I'm sure that they can't get to the board before they can't hear, they're always going to do. Oh, you can't talk me, you can't pick up other certain things. You know, even the fact that I can sit with you and talk to you, while the others are off. So if you have a question, I can always answer that, we can always discuss something. You know, they're always. That's part of. You're supposed to put them on. No, interesting practice.
He knows what to do already. No, he knows what to do already.
And she has some medical issues who can't work. She sleeps. I can't answer that part. Well, she wasn't here. She wasn't here with me. No. She didn't do it. She was not what she's been doing, I can't address that. She's been in the board. She has to get up her.
I won't be here next week. So I have to make up. So you have 3 times the week after. And then assignment sheets. So they can work on this. There's a micro teaching. I don't know if you want to. I'm also going to give it I don't know, like you're supposed to teach a topic that is on grades 7 to 9. Because this is a course that you look at your course, like you get what happened? No, but
not useful. The people that I interact with are great.
But look here, it's a 79 foundation is going to help them. Don't believe that. Because even though they're in grade 10 and 11, a lot of the foundation things are missing. So sometimes you have to step back. Yes. So this course is really focusing on the grades of 17, but what they should know here, or even the little basic things that they should know, but they really don't know. They should pick up on conversation. But the truth is, for you to be effective and be able to move with the lesson, you have to step back. You only have to step back and address, and you can address them, and they won't be able to do. So for the next course, which is for grades 10 to 13, so I've been on this foundation thing. It is the next one will focus on how do you teach these things now. So if you teach in variants are really a foundation. We have to know a lot of things before you can variants. Yeah, it's a different stuff. There's no whole lot of things. So you have to understand angles. You have to understand the corner points. You know, there are many things. How you write here, all of those things. So for
for you to, and trigonometry, that one of trigonometry. So for you to be honest, you need all of those prerequisites. So you have done all, that's why your foundation is important. Because also the kind of business. Now, how do you teach parents so they just get a good understanding, a deeper understanding of theory? Even though it seems kind of abstract. How do you teach trigonometry? You know, because I don't do trigonometry. There's no certain things already, don't it? But then they get a base element, you know, so that's what we look at. I look at the C-section syllabus, I look at some of the errors that we make in doing C-section, how we can go about correcting, preventing the errors. Someone told, I think it is, this one is just this course. If I don't teach a lower level, it should benefit from it. Because if it honestly you get in these areas, and when you see certain misconceptions, and you have a very weak student, you can put them on and look here, let's do this together, you know. So if you can do all the students and say, let's look. It doesn't matter if you're not the brightest class, you still have to put out one on top to show them the things. Even when you teach at one of the prominent high schools, primary is probably one of the most prominent high schools on in primary, it's not special struggle in that exam. So you still would need to pull them out and show them the little things that they really don't know. So even the angles concept that they don't understand. They can't, you never said this, the angles of things for angles out of this. They don't really get it, and they just know that. They don't really the concept behind it. Even if you have an alternate angle, they can, they're active, they can do stuff. Measure it without even a protractor or anything. Just, you know, even a piece of paper, you know, show it around and just get that together. So even these little things, these little tricks I can teach them to make math a little bit more. And then they could still understand that cognitive problem. You're powerful.
People from the Einstein and there they are by choice. Einstein people are very interesting.
I teach I teach now. I teach students who are taking by choice, and we don't always do anything. Even the ones who are interested, they're interested, but they don't know.
When they come to club meetings and so, it's different from going into a class.
But you can challenge them even if because you really math for a long time. You challenge them too. Challenge, like, you know, just give them show this and they have fun and give them the right song. And games, not games. I don't know this person, I don't know how much time they have. Who's the expert of games? Like, so for example, let's say we're doing like this, and let's say we're doing this one. I really don't know this. You can add it again. Understand it. So let's, for example, they're doing this one. I think this job was great. I played the other game, and then I just write 100 and say what's the biggest. Just to the left of the guys, I'm going to come here and try to make the biggest possible number. So that will idea of place for the community that you'll see some things. So some of them throw 2 and it puts in the first column and they don't know that. All right, let me see. How can I get the biggest possible number? How the probability and the probability comes in. So you have a game like a challenge game, you know? And these are simple concepts, simple probability, simple place value, simple basic understanding. Next struggle. And you don't believe it.
It's how you, it's teaching.
To teach it. So why did I know?
Interesting. And well, somebody is going to have to keep some
Oh, so kind of what do you?
My son is autistic. Somebody. What I see happening coming home, and I'm not exactly sure that that's the way. But
that's why he's scores.
That's why he's here. Yeah, you know, manipulatives. Those things with the X square.
Even the grading level, trust me. Look here, I took the instruction. I fixed myself. Draw a diagram. The 1, 0, 2, and show that. Half times 1 is plus that. Draw a diagram. And they show the draw diagram. Show that. I said, what did you hear before? In a I said, draw a diagram to prove that 1 divided by 5 is possible. That's true. Because exactly that's what I'm doing now. I think a whole but a whole lot, a very long time ago.
Especially the last one.
So the point I'm making is that we all have
I've been struggling with that. I've been struggling with that.
I just don't think personal to anyone.
I've been struggling.
I didn't learn like that, so
I've been struggling.
how many candidates did you want? Say the balance of 8 and look at the remaining compares. And let's see how much it's taking you to think. Yes, that's the thing.
But not everybody is a grade 7 with the past.
They wouldn't. It's true.
I have to take all the way back to the number line. All the way back to the number line.
No, because you see, as you
Well, she has been
say,
struggling. She has been struggling.
So my time, a lot of our students, they don't want anything for them.
Because they're cultural. But look here, and the thing is this, you know the same thing, I'm writing a paper now today, and it's the same paper, I'm arguing a paper that the job that we have in math job that because they're not taught to think. They're taught to do procedure. So that's when the kids are sitting more. Yes, the kids are sitting more. They're not getting formula Steve was a little one that you can and so they're trained to think. So that's what we're trying to do. Something we're not expecting over there. Lots of years and they've been to the effect change. Lots of years.
To undo this education.
Develop the idea of the understood
And not only do you get on the field, I feel like I get down to the spot. And I'm saying, like, I've been there with some certain things. I can't wait for the But yeah, that's the thing, we're not. Because I'm not challenged to you with these things. I don't
Certainly. Certainly.
They're not sharing what happened in the budget. So when you push and people can't push them.
But we're at 7%.
I think it's about 3 years. For the person, 3 years. Yeah, that's part of it. But they're not doing stuff. Not for individual, of course. But they have.
The individual doesn't live there.
That's what I said.
They can't do one year to the extent.
Right, that's the thing.
The individual, yes, same thing, and you are.
Yeah. Yeah, same thing.
Our weekends are for. After they increase all of this taxes and all of this. 4%. It's
EPA, right? When they can't just fix it, yeah.
They take it off themselves. So we can ask them that. Some of them not doing it. So many people in all over the past.
They're very grateful. They get all of these grades.
No, it's not great stuff. Fine, you get grades. Probably not the one you get.
And they're very creative. By the time they're screwed without their creativity.
No, my problem is one.
But it's
$1 million they tax a year in
And
1 cent.
that's it. But the thing is,
But they've been under.
they are so creative that they can get all of these things.
Oh, so they can have
By the
it
time
done.
they're done. By the time they're done, they're Look at it this way, if you're getting on this event, you get a 10%. Nice and cheap. Exactly. What is that thinking? Expensive, right? Has to be.
They're doing 2 month courses, right? No, but this it's on the one. No, this is. We do 2 next for summer. Okay, that is good. Because I thought you were going to investigate and nature. No. Huh? Oh, so much is seriously too much. One is Victoria. Right, you said to you.
Huh? I reserve that. I was about to say something that
Someone is going to be up there for an hour to get up.
No.
No, you can take it. We don't know the thing that brings them, and then they're having it. These are neat. All right, so you people will teach greater level again. Because I'm from really small and he would say like 3 times x plus 1. 3, or you have like 3 bracket x plus 1. You can represent 3 groups of x plus 1. You should have very easy. Especially for this role. So you know how when you're doing it, fine, and they will have the square root of x. And they add the x square and the x, and you have some number like x. So when they have a different thing, like let's say I have x square, and then they're adding the x. So it's not, technically we should be able to do it, because it's 7 x square. Let's say I'm simplifying, this is my first. I'm simplifying x square. 2x, 2 x squared, But when the thing is this, when you're adding now, what happens is that you don't like one, the one that is like this by itself. So again, this is easier for them when I'm doing it now, not to be putting them together. But I look different because this is different from this. So in their mind, or they sort of figure that x squared is different from x, and you know what I'm trying. So they don't make some errors when you do stuff. And if you complete the squares, easy. They can even, so some of them don't even have to actually do it. They can just use the algebra tab and put it there. Or at other times, some of them will just draw it. Yeah. So, the next one. Well, we're not using all of these. I just put it down, of course. Because we have to dare to do to the ground. That's the point of it. You know? And even this is what we're currently talking. So, in your class, just put maybe a marker, or you can use your students that they can use paper. Let's say you want to say draw a shape with a pyramid of 8. They do that the experiment. So they're gonna come here. Some of them start on 1 here, but that's not 1. They call it space. 1, 2, up. Yes, but then you get this dialectic and major concept when it's the best of 1. 1 must represent a distance from here to there. Must be, you know, people are measuring distance. Yes, I teach complete space. 1, 2, 3, 4, 5, 6, 7. All right, so it really takes some thinking to do too. It was like draw a shape where the area. It's about area. The area is 10. So you know that this would be so because area is like number square. So they need to get 10. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This would be, you know. So it takes a lot of. Okay. Really helps. So it is the concept. So I'm saying, so it's really, so they can, some of them, if you have the square tiles too, they'll just put it there too. So they'll tell you that square that makes what, it's even the same. What is your bottom now? Pocket cubes. Yeah, we have cubes. But it's just a cube using the ones that we make. Let's pop the cube and then count how much cubes and that's it. So they get the idea. Even your report formers, even introductory activity, you can use this things for. And you can this function here. It's serious things for students. Really, really challenging. I just answered the problem. Even the timer pieces, just say they see how special over there. Use 2 pieces to make a rectangle, 2 pieces, and 2 pieces to make a square. Use all of them to make a square. These things are the same as ours, but you see how much thinking it would take for them to do. Alright, we're back. Yay! All right, so we're going to now take out our scissors, take out our pieces. Good idea. I think we should sit here. So we're going to take, so looking at the baseline blocks first, that's what we're cutting out first. Alright, so we're getting our scissors, our baseline blocks. So we'll take out the baseline ones. I will get our scissors, please. So and they should be laminated and just that you've done your assignment.
Yeah, I know. You see, when I have person who teach you how to be independent. All right, guys. So this is your base pen. Remember this? And you have it laminated, right? And when you look, you see 6 of these. So you're gonna cut out all 6 right now. Can we go ahead and do that quickly? All 6, we're gonna cut them out so we have only them look like this now. Good? Are we all working? Tasha, where's yours? What's up? Let me see it. Yana, let me see yours. I'm not hearing you, Yana.
It's like I sent it to laminate. You were supposed to bring it for me, so I'm waiting for them.
Oh no. The others are for us. Do we have our things? Tasha? Where's she? All right. So you have all 6?
Cutting them out.
Okay, cutting them out.
They don't work. I'm waiting for them to comment on the retest and on and then something is wrong with the correct commute. I'm thinking of driving tonight. Nothing is better.
All right, so what you're going to do here. So we have 6 or 4 of these. These ones, we're going to cut them long. We're going to take the wood in here. So you're going to take. All right, so cut 2 of them. Not these. Oh, you can cut these too. Because we don't think that. One of yours. Yeah, all right. So I know them too. They're going to cut That's fine. Are we finished? Still working?
Finished.
All right, so we're gonna cut. Let me show you now. All right. So from 2 of these, we're gonna use 2 of these, and we're gonna cut them up into this longs. You remember the longs? Are we following everybody? We're going to take 2 of this and we're going to cut them into longs. Sabina, you finished? Sabina? Are you there? They're not hearing me. Diane? Are you still
Yes.
working? Are you still working?
Yeah, I am.
Yes, we are cutting.
All right.
Yeah. What is the question?
The longs, let me look at it. Hold it up again. Good. Very good. So, finish. When you're cutting your longs, you're going to take what you finish your longs, just in case some of you are moving ahead of others. Listen, just in case. So after you cut 2 of these into longs, you're going to take 1 of this and you're going to divide them into units, just a little squares. Are you following? So, yes, so you're going to have 3 of the flats. That is going to give it 20 longs and 100 units. Are we clear? No, you can just leave this for the moment. Yeah, I will. So you know, with these, let me tell you, you can use these to teach as undertone. So you just write numbers in it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's to 100. And then you can ask them to shade all the prime numbers, or shade all the even numbers, or probably all the factors of sorts. So let's go through and shade them all. So you will know what to do in the case series, okay? Shall we just consider more like this transition in the ones, like let's say the nation so that's why you don't need to go something. So why because the new learning?
How many?
I'm here.
How many single units again?
20. So you're gonna say so 20 of them. So let me show you. So 2 sets of these, yes, Tasha. 2 of this is going to be cut like this.
I have done that already.
Both? All right.
Yes.
Get 1 of this and get 100 units.
Or small ones.
Very tiny ones now. Good.
Okay. Wow.
I know, but you'll see how you can use it. I know. So the reason why I told you to do this is in class because something I said to something different. So I'm like, what is that what I say? But you know, people hear what I want to hear. So they're going to go to class. Not the same person before. This one? But the teacher was right.
You know.
They say you pass 8:40. I want you to make it up the same for the oh, you need the program on the course program. Oh, because last year I was third time. First year. So, I was teaching the course. January. But then, because I'm a student, also I had 2 meetings. But nice one, I love it. Which one? What children are mathematics? Somebody eat this? What did I do?
You didn't teach her. What you did is what you didn't.
You have the scissors? You didn't get the list for the math kids? I didn't use the scissors. You didn't use the scissors? I'm sorry. Hey,
I'll just watch when I get the chance to tomorrow and do what I have to do.
Just so that, not so yourself. Like,
when you're working at that place, you're not going to always sound like.
No, man, I know that. Look here. I'm having a problem with the internet, and sometimes I'm being very busy.
No, the laminating, I didn't want to get to class late. I could have done it little, but I didn't want to get there late. So, I mean, instead
because
of
if
doing
you cut it out first before you laminate it, then you're going to have a problem.
Yeah, no.
Yes, it's going to cost more.
I figured it was something with cutting out, so what I said, I'll watch and learn.
I probably could sit here with them then.
So is it like case we're just going to cut out all of these blocks?
Not all of them. So you keep 3 of them for the flats.
As in, like you're going to make 100 of them.
So 3 of this for the flats, 2 for the longs, and 1 for the units.
3, 2, 1. 300, 210.
Sorry.
I still finish now, Zana? I'm not hearing you.
I have it on laminate, so when I get it laminated, I just have to do the same thing over.
Okay.
Yeah.
All right, so Jeffer, where are you?
I'm here.
Are you finished?
I'm trying to finish off the units, cutting the unit.
I know it will take a while. Dan, where are you? Tired?
No, I have my unit.
Oh, good job. Good, very good.
What are we doing now?
You're finished?
No. I'm asking.
Did you make
this? Are you hearing me?
I'm hearing you. I don't.
Oh, I said I got disconnected. I'm not sure what we're doing now.
Okay, all right. All right. So this is where we're at. We have these.
Yes, I have them.
All right. So you're gonna cut them out. You're gonna have 6 of this. Do you have those?
Yes, I have.
All right, so you're gonna take 2 of this and cut it out into longs like this. So you're gonna get 10 longs each. Good. And when you're done with that, you're gonna take 1 of this and then you're gonna cut them out into units. So you're gonna get 100 units from this.
Okay.
Are you clear?
Okay.
So much cheese.
Then, look for this. This is not dinner, it's a habit I have in her head.
This is dinner afterwards.
Really? She was so pleasant the other day.
Not every day.
I think I prefer the other day. Go back to the other day. She's I missed the other day already. Like, you know? Please. Come back outside and come back the way I love you. Girl, come back.
That's right. We'll come down. I just don't think I can do that.
I was up
All right. So we're going to time round. Two makes the. You finish your chart? Give me your flow of spirit. I see. See, put those things one place and then borrow some of the store Not today. The next day. So we're going to select them. Pick up a time round now. So we're going to put on each of the shapes.
All the shapes.
Put it this way and then you do it.
So look at here.
Miss McCarthy?
Yes, ma'am.
What should we do after we're done cutting?
All right. So you remember those little bars that I asked again? You're gonna put everything up good and put everything that you've just did. So all of these blocks and put it in that as a bag.
Okay.
And then you're going to search for this tangram.
Oh, okay.
So
are you cutting the parts of the tangram?
Tangram?
Yeah. Are you cutting the shapes, the pieces?
Yes. So you put these shapes. You're going to cut them out individually.
Okay. All right.
So you're not going to mix up a tangram and your Dean's blocks now. All right. So that when we're ready to use the Dean's block later, you can easily identify it or find it. So we're just going to make all these manipulators first, and then we're going to start using them. So today we're going to focus on using the Dean's block. All right? But we're making all of them first. So next class, we don't have to be making manipulators. We have all of them already.
It's not nice. It's not. It's not. It was very much longer than I woke up. Five? It's from them. From them time they every time I have to put scissors some places where they work. And you still one night find out you can and find it. Feel like you doesn't like scissors. And nobody likes scissors.
Children normally put their own hair.
He cut his lips right here.
So he didn't,
Yes, and he didn't like it. He said this wasn't supposed to be, this was supposed to be straight. Yeah.
All right, so at the end of the tandem, you should have different pieces. Looking something like this. If I can see. Can you see? So you should have 1, 2, 3, 4, 5, 6, 7 different shapes when you're finished. Are we clear? Good. Very good. Darren, let me see what you have so far.
I'm still cutting, but I have my.
Good, very good. You did the right thing. And Sabina, let me see what you have. Tasha, where are you? Tasha, where are you?
I'm still cutting. I'm almost done.
Hi, Sabina.
I'm here, still cutting.
Okay, so you should have different shapes. 7 different pieces.
You know.
Okay. Seven. Yeah, that's it. Then you start. Well, it's not one set, three sets. And 3 box.
Yeah, so that we don't have to do it again. You should be
One red. You did it right, 1 red and 1 white.
1 red and 1 white.
Because the red is for the negative and the white is for the positive. And yes, and even I thought you got the notes. I thought I saw you writing. Alright, so this can stay. It's fine. This is fine, but you can get community on this. And then this note will be nice and how it is in different colors. So each of these circles, they can be as a mark or something. You mean the circle? Yeah. So we put this in the second with different parts of the circle. So let's look at this.
Can I just print these on different color paper?
Sure, that's an option too.
But you're gonna separate the circles and put them in different.
Well, you could probably have 2 to be the same color. It's just like when you look at this and this, it's kind of hard to differentiate.
Right, if they're the same color.
But I would prefer to have each circle different.
Even to the brother collects nice.
Or somebody else
say if you like the size of the pieces.
Oh, you can do that, yeah.
So you could write one third.
One third. One, two, 3, 4, 5. 1, 3, 1, 2, 3. So that you can do it. Are we finished?
Yes, we are.
All right, so we're going to look at the next thing. All right, so this is the algebra tiles. You should have a red and a white, remember? Do you remember that? So what we're going to do, so you should, for the algebra tiles, you should have your red and your white. So you're going to cut out each of the pieces just the same. So you're going to have the x squares, the x, and the 1, okay? For both red and white. Can I see the red and white? Everybody? I'm not able to see you guys. I don't know if you're following me.
I can hear you, but I'm sorry. I did not have my instructions with me and I forgot I was supposed to get red. I only have white.
Oh, but you will need to get the red by the next class.
I understand. Yes, I'll get it.
Then when you're doing negative, the red is going to be the negative. Okay?
Okay.
If you only have white, it's good. You can use both whites, but then you need a pack of red also, okay?
Yeah, I understand.
Because yes, because if you don't have it, when you want to represent negative x squared, then we're going to have a problem. Because the white now is going to be the positive x squared and the red is going to be the negative x squared. When I want to represent negative x, I would use a red instead of a white. When I want to represent a negative 1, I would use the red instead of a white. So you need the red to be able to represent your negatives. Okay, Claire?
I didn't get the red either, but I'll get it for next class.
Yes, but but you can use both whites for now because you'll be able to use it to the students anyhow. You know what I mean?
Okay.
So it can't be too much. So if you have 2 sets, it's fine. But you also need the red. Cool? Yeah, you need to separate them. Right. Yes. What is fine? Yeah.
Pink is actually red somewhat. No, you did art, red and white.
Think it's red and white?
Yeah. For sure. Wait,
So you need to your effect. You need your effect, your things. Okay? But no matter make it, you don't have to make it.
I know exactly how it is.
instructions. So that tomorrow in my brain is. That's right. You are not put your names, that's why.
No.
No, they
This
will
is not- this is something-
Yes,
this is
exactly how to. Right.
This is something- this is-
It's helpful, but you
don't think they're being opportunistic when I have to take them to school?
Exactly. That's your priority. Really, no. It's still your priority there. And then when people ask you questions like, hey, what did you for? I use this for. And yeah, work experience. I had to babysit, so I know the feeling.
Yes. Because she should be able to explain. So then we'll get to the next one. So it's circle 3? Yeah. No, the gym was finished. Ah, yeah, she's kind of okay, guys, if you don't have bags, you can get like envelopes and stuff, so you can put your things in there, okay? Individual things if you don't have bags. And you just label it, so you don't have to throw everything out. But like before you something like this, you learn to add your time. And then after this, you could be a cycle. Just keep that. All right. So I put first and then you get balance. But you have some because either like even the earth show they have some little scissors. Like round tip scissors. Yes. So that's all I food. Yeah, them more blood than that. Yeah. Yeah. So we have scissors. So that the earth show says something to the grammar. So for the basics, that's to be put in. They can look for so crazy. I just get to one and then probably show them so don't worry. But you're not going to sit on all this one. Just have your respect for your demonstration. You know the real things, no? You know the real advertisement? I think they're 3D. They're 3D. And the dance block also 3D. So when you teach it, so now we're going to teach body now, which is the unit. Yes, okay. We're going to teach body now. Yeah. So these are the template because of that Jamaica don't have a money east still, we just like a money to die these things. But the idea is that we can always make them use like cardboard or something. Finish? Alright. So what we're going to do next is this. I am not going to add so we only have the fraction pieces, the circles to cut out, okay? Because the other thing, yes, then let me look. Could you all of it up again for me, please? Oh, because all of this entire circle should have been the same color. So all the thirds should be the same color. That's how I would have wanted it. All the like let's say the halves could be blue, the thirds could be red, the fifths could be green. So that the idea is that when you pick up your paper, you should be able to say identify 1/3. After a time, just get it in their brain and what the thirds are, the X color or whatever. So they don't, because when everything is scattered, it's hard for them to be able to just look and pick up. Like even 8 and a 6 can look so close in size. Are you following them? Everybody following me, Sabina? Good. So we're trying to get all the halves to be one color, all the thirds to be one color. So one of the reasons why we wanted to do this in class because I wanted everybody to be doing it and doing it right. Okay.
So we want them in the same color, but
no, just it's fine.
So I can probably write them in different color ink.
It's fine. Just laminate it with the writing on it.
Yeah, and then what I was thinking
it's
is
fine.
I'm not coloring. I mean, I'm color it over, right? It's not going to be a
You will put it on to
the same time.
Should be going over the edge.
Yeah.
So what I'm thinking of, so this would be, look, everybody focus here, this would be the 1. And so when you look at so the yellow, all the thirds, so over time you know that the thirds are the yellow, so that's how the color was important. So when you look again, you see probably the 6, the 8, are in another color. Then you have the green, probably these are the 4ths. So that's how we want them, okay? Now I'm not going to allow you to cut out your fraction pieces today. I am going to take it that you can do that for your assignment for the next class, okay? So we're going to move into using the manipulative. No, because I still use it today. I'll send it on. I don't worry.
What? Hello?
Yes, I'm coming.
I was facing some difficulties with my connection. What is going on? What are you all doing right now?
What have you done so far? Have you done all of these blocks?
Yes, I have done these.
All right, so that's what we're going to use now, okay? So you need to now you have to do your algebra tiles and your tangram on your own. You're gonna ask for help, right? So you're gonna WhatsApp somebody to figure out how to do that. And for your assignment, you're going to work on your fraction pieces. That's the circles. You're going to cut out the individual circle, the pieces from the circle, okay?
Okay.
Are you clear?
Yes, I am. Thank you very much.
All right, everybody. Now, as was said by Deans, as I said before, he's the person who designed these blocks. They're going to put away everything else, and they're going to only have on your table or desk or bed or wherever you are your these blocks. Everything else is going to be put aside, okay? Are we ready? Are we on the same page now? Now, the first thing I'm going to allow you to do is to take 5 minutes to kind of look at it a little bit and think about it. What topic could you use this to teach? Not the ones I'm going to tell you, but how could you be creative in using all that you have here to teach something? I'm going to tell you some, but the idea is that we can use whatever materials we have to teach other things, many other things. So it's just how creative you are. So you're going to look at these books and tell me, what topic will you use to teach? Area. All right, we can take 5 minutes so we get some thinking time for those persons who are not very sharp. All right, still need some more time? All right, give it 2 more minutes, okay? So just think, what if I have these? What can I use them to teach? Because the idea is that we can use even things in our homes and just carry them and teach a lesson. So you're not going to come in her idea. Interesting. That's the idea. Simply as though one like the older ones can understand. You're probably going to understand. Simply you can, because what makes a good teacher
is that you see when you reach up some advanced level, you'd be surprised when your 8-year-old brother actually you have to fix something.
If the little things make you able to understand the bigger thing.
Like there's some dots.
No.
Or you're just looking for some advanced stuff that you switch yourself your brain in calculus. 8-year-old has to say.
Do you know that they actually say what makes you a good teacher is being able to take a very complex thing and make it very easy. Yeah, that is what exactly what people
I just have to tell somebody about the grading. I'm like, poor child don't understand grading. It's all right, that mountain, you like mountain, right? Use that.
I use a slope, but they don't the same slope when they're going uphill. Are we ready? All right, so as I was explaining to the students in the class here, I was saying that what really makes us a very good teachers is the ability to take abstract ideas and express it in a very simple way, all right? So, I don't know who I should start with. Should I start with Dana because she's so small? And Dana, go.
Yes. Dina.
Dina.
I'm actually thinking about the multiplication table, you know. I don't know why.
How would you use to teach? All right, can I hear Dina? Everybody? Am I hearing you? Can you hear Dina?
Yes. Yes.
Like the one with the 10s, it just kind of caught me. I'm saying, you know, groups of 10, and then you have one group of 10, you have 2 groups of 10, 3 groups of 10. That's basically you saying your 10 times, your 10 table. 10 times. 10 ones, 10 twos. Like you have 10 of this one, 10 of 2 of those, 10 of 3 of those.
Okay, good.
And I was just thinking about the multiplication table and 10 times.
All right, good. Would you agree with her? All right. So you're next.
Yes,
After this,
Well, it's 10 long, but you know.
you're next. All right, go Ingrid.
I was thinking multiplication.
Also, yes. How? Come show us what it's.
For example, if you want to multiply 2 by 4.
2 by 4, very good. There's arrays.
2. And then you multiply that by 4. And all of this you're counting.
And then it comes very good, very good. I thought then it would have expanded on the 10 times. Okay, are you understanding that, everybody? So you could use it to multiplication, or we call multiplication arrays, make arrays. So a 3 by 2, you multiply 3 by 2. So this will be my 3 by 2 rectangle, and the number in there will give me the answer. You use it to teach multiplication. All right? Yeah, you're next.
Okay.
So you need to comment. Tell us.
So area, and in an area we have the concept of the square, so it's not just, it's not just 5 centimeters, 5 centimeters square. So here we have in our units a square, and we could say, all right, if we have, this is 1 squared, and if we use 2 of them, so it's 2 long and 1 wide, we have 2 centimeters squared. If we have, 3 times 4,
All right. So we could expand on that a whole lot more. A whole lot. Are you following that?
Squares, you would actually get
yes,
twice the amount of.
So let's look at the concept of developing the formula for area of rectangle. Draw me the size rectangle. Dot it. And count how many squares make up that rectangle. And you record that. Do you know the relationship between the length and the width and the total number of squares that you get? Are you following everybody? So so do you know? We're gonna look at fraction. So then look, can you see the relationship there between the length and the width and the total number of squares? All right. Divide that rectangle there into 2 triangles. How would you prove? So you can come up with a formula for triangles from that. Yes, man. So when you have your rectangle, and you divide the 2 triangles, you know that this would have been the area with the length and width, and it would have been half of that. Are you following what I'm saying, everybody? So we could do area. So we could even do just about. You could draw anything, any regular shape, and call the number of what squares, and you can find it. So many things. When it comes to area, you can really
Interesting. You can even use
a parallelogram.
You can draw
trapezium.
Get a right angle and let them get the area of it too by just drawing some random line, and who knows that then
the right angle,
the right triangle. Yeah, right angle, and like the Pythagoras, they already have the width and the length and the base, so they can find the hypotenuse or stuff like that.
Are we seeing how far if we really extend our minds, how far we can go just with this alone? Pythagoras' theorem and stuff. And then now, so you're next.
Okay, I'll use these to teach place value.
Good. Very good.
So a very good concept of teaching place value.
All right, tell us how you use it.
We have the units, the long and flat. Now, the units represent 1, the long represent 10, the flat represent 100. So right away, if you add up one of them, we'll actually get 1 to 9. Yeah.
Good, very good.
We can even represent 32, 3 long, 2 units.
Very
so
good.
We can use to teach place value. We also can use to teach decimals, percentage.
Percentage. Let's talk about decimal, because we're going to go into decimal later, because that's one of the activities I plan to do with you. But look at this. This is good for percentage, don't it? What is a percent? What is a, tell me what's a percent. More, a little bit deeper than that. Who wants to tell me what percentage is? Yes, 100%, a little bit deeper than that. It's a fraction that
with the denominator of 100.
It's a fraction with a denominator. So if you write now half, if a half of write a half as a percentage, you can think of what a half of this is and have them just share it. So that percentage idea, or the right equivalent fraction where the denominator is 100. So this is very good for it too. And it's good for decimals.
And then given that it's 100, 30%, find that. It is
30%, you shake 30% of that grid there, 45%, 75%, many ideas.
So having gone into percentage, you're already into fractions.
Yeah, because percentage is a type of fraction.
It's a type of fraction.
Yes,
They can use,
it's a special type of fraction.
They can also use it to do fractions.
Very good. Even decimals, there are special types of fraction. What are decimals? Who wants to tell me? What are decimals? Anybody? Jeffrey, do you know? I'm not hearing you.
Fractions of powers of 10.
Very good. Very good. A decimal is really a fraction where the denominator is a power of 10. So all of these things are fractional. So if you understand them properly, they're all fractional ideas. So all these are linked. All right? So we've exhausted everybody now. So who's going next? Sabina, you're next. What would you use this to teach? Anything about this to teach?
They have just mentioned everything that I have on my paper. So I had area, decimals, fractions, and percentages. All of those have been. I said all of those that I had listed have been mentioned.
So for example, so just tell me them nonetheless.
What I had area, I had fractions, decimals, and percentages.
Very good.
That they have mentioned.
Very good, very good. Tasha?
I'm here. The stores all my examples has been exhausted, has been said. Especially the level I teach, decimal, fraction, times table, place values. So everything has been said.
All right. Very good.
Can you use it?
Okay, go Jeffo. Then I'm going to come back to Diana.
Can you use it to teach subtraction as well? To the lower.
Very good. It could be used
and addition.
Multiplication, division, all of those ideas. Good. All right, Diana? Am I hearing you, Diana? Diane, can you hear me?
Yes, I can hear you.
All right, what would you use this to teach?
Extended notation.
Tell me that one.
The big, like 164, expanded notation.
How would you use it?
The big one will be the 100. Then you have 6 blues will be the 60.
I see. Yes.
And the 4 small ones could be the 4 units.
All right, so it's going to be 4 times 1.
Yes.
And then this would be 6 times 10, as you can see.
6 times 10. So 6 of them, yes.
Yes, and let's say a 5 of this would be 5 times 10.
5 was, so it'll be 564. Or something like that.
Very good. Am I missing anybody? Am I missing anyone? All right, so this is what I'm going to ask you to do. The first activity I'm going to ask, so today I'm open to look at decimals and just addition and subtraction with renaming. So the first thing I'm going to ask you to do is, I want you to represent 22 in as many ways as you can using your these block. Represent 22 in as many ways as you can.
You're right. I'm gonna write the rules.
Alright, so how many possible ways you came up with, Tasha?
So far, 2.
2? No, they're
too long. No, too long. No, I'm still working.
Still working? I'll give it some more time. Sabina, how many possible ways you came up with?
Well, I have 2, but I'm not really sure about the second one. The first one is too long plus 2.
I'll work on it a little bit more, Sabina, because it's more than 2, so work on it a little bit more, okay?
What's that? Okay.
Alright.
I have 3.
You have 3?
Yes.
Diane, how many ways do you have?
So far, I'm only on 2.
All right, so I'm giving you a little bit more time. So for the persons who have 3, how can you think about this question in the meantime? So I don't want you to, you're not really ahead. I'm just giving you a little thing to think about. How can you know for sure that you've come up with all the possible ways? Just think about it and hold it there in your brain. How can you know for sure that you've come up with all the possible ways? Think about that, keep it right there. For those of you, continue to work because it's more than 2, so continue to work. For those of you who have 3, think about that question. Oh, I never come back to you later.
I'm saying my brain always go all over the place.
So share the idea that you were telling me.
Oh, I was thinking about, look back centimeters and then I saw decimeters.
Ah, that's very good. So remind me to. Yeah. Yes, it's very, very good. Very, very good. For teaching measurement.
CDs that brought that.
And also like your contaminated curve. It can be done. It can be handed to your algebra evaluation. All right, it's too many things. So, remind me to make sure that's the order. So we're going to coordinate. If you can say this is your x and this is your y, and then if this is your 0 point, you can have the middle 0 and marker. I'm calling it 2, 3. We're calling 2 along here and 3 up. So the initial stage of
Can't make children bored.
Vectors. So you can do. Trust me. For grade 10. So, all right. So please write those notes.
So many ways of calculating how much grades.
All right, are we finished? Please write those down so I can remember to share with the others.
You said 22, right? 27.
22. All right. For those of you who had two, how much do you now have Tasha and Sabina and Diane? Tasha?
I have three.
Okay, Diane, 3.
No, still on 2.
All right, Sabina?
Still have 2.
Still on 2. All right, Tasha, will you share the different possibilities that you came up with, please?
Okay, I have 2 longs, then I have a long and 12 units, then I have 12 units, 22 units.
So you have 2 units, 2 long, 2 units, and then what? 1 long and 12 units.
Yes.
All right, so did we all have that? So this is it. We should have our 2 longs, 2 units, that and that. Now the question is, who should I ask this question now? How do you know for sure that you've given me all the ways you can represent 22? How do you know for sure? How do you know? You see how these questions cause you to think? These are the questions I asked in your class. How do you know for sure that you have given me all the possible ways you can find 22? How do you know for sure? How do you know for sure? How can you, what rational can you? Yes,
I think it's the right method of elimination, because if you look at, you could not have used the 100, the 10 by 10. So you went down to the next largest unit, which was the 10 squares. And you started off by using 2, and then you went down to 1. So it meant that you could, and the last one is 0.
Good.
And then for the singles, you started with 2 and you went up to 12, and your most you could have used in the singles was 22. So that basically meant that you have already exhausted all possible options that you have to represent 22.
Well said. So look here, it's the idea of rename. I rename one of these to 10s. Look at it. That's what I did. So I know that this is really 10. So I just exchange this for 10 of the units. Are you following that? And then what else? I still have these that I can also exchange for 10s. So when I look here, if I exchange everything else, then there's nothing more to be exchanged. Well, very good. Very good, Zana. Well said. Good job. All right. If I were supposed to, so the next question is this now.
Miss, because I was,
yes?
I guess I was thinking about something else. Because we weren't supposed to use these.
No, man. You could give it in because it's 100.
Yeah, I know. It's just, I was thinking like shading out 22 and shading out 88. That's
all right. So if I should ask you to represent 22 using the least amount of material, what would you use?
70.
The first one. 2 longs, 2 units. So you're building the idea. All right. This is the next question. When you have the same number of groups to represent 27 as it is to represent 33, and how do you know that? Think about it.
Would you have the same number of groups represent 27 and 33, or 27 and 22 and 33?
No, 27, 33. Would you have the same amount of groups?
That we had.
So in the first one, how many groups you had? 3. Did you have 3 groups for to represent 33, less or more? Why and how do you know?
We would have more.
Are you following me, Sabina? Sabina, I'm not hearing you.
Yes, I'm following.
Are you following me, Tasha?
Yes, I am. Yes, I am.
Are you following me? I'm not hearing Jeffer.
Yes, I am.
All right, did you hear the question?
Yes, I did.
Oh, did you understand the question?
Yes, I'm trying it right now.
Okay.
You mean by groups, you mean ways?
Yes,
Like ways.
Do you want us to answer the question or fine? Because
At least four.
Yeah, at least four.
Four.
Eliminate that 10 every time.
27. Yeah, the five group.
What do you mean by the number of groups and the different ways that they?
Ways. So in the first.
Yes, you would have the same ways. You see, we would have the same number.
We would have the same number.
Yeah.
Okay. All right. So you're gonna tell me the rationale for saying that then.
Yeah.
What's the rationale?
You want to?
How do you?
Okay. Well, if you take a look at 27 and 33. Basically, we remember we own the almost the same thing like we explained earlier. If you we are going to start off with two 10s and then go down to 110 and then obviously we'll go down to singles. No?
Yes, I agree with you.
For the 33 though, you will start off with 3 10s though, go down to 2, so that will be 4 ways. Go down to asterisk. So it won't be the same number though.
Ah, good. You catch up on yourself. Ah.
It won't. There'll be 4 ways for the 33 and there'll be 2 ways. I'm sorry, 3 ways for the 27.
All right. What conclusion can you draw from that, Jeffer? Having done that, what general conclusion can you draw? What general conclusion can you draw? When you look at
the larger the number, the more ways there will be to using the.
Think about it, the larger the number. So if I have 53, I have 5 different tens that I can break. Are you getting that? So the larger the number, the more, yes. In terms of, not large, in terms of 10 increasing by 10. Yes. Very good. So if I have 33 and 37, it's the same number. But once I form another group, then I'm going to have more. Yeah. Are we clear with that? Sabina?
Yes, we are.
Sabina?
Yes, I agree with you. We are exchanging, as you said originally, groups of 10. So every time you're breaking down a group of 10 and exchanging until there's no more.
Very good. Well said. Give it more ways. Good job. All right.
Actually, you said something and I said, I actually remember that number. Number of 10 plus 1. Number of 10 plus 1.
Number 10 plus 1.
N plus 1 is pattern. Exactly. So I tell you see, even algebra, look at how bright you all are. Even the algebraic concept. So somebody was saying, no, but do you see the math got a little bit more interesting when you have the things that you can ask the right kind of questions and get the students to think and all right. Now
continue, Miss.
Where were you last?
All right, so let's look at this. Let's look at this. Somebody was saying we could use this to teach graph. or especially just teaching the students how to plot points. So you could use your marker and create a nice little L right here. So for L, or depending if you want to do a T, and make your 0 point here. So if I need to plot the points 2, 3, I'm counting 2 places, 1, 2, and then I'm counting 3 places up, depending on if it's what Cartesian place you want. Is a positive or both positive or negative. If you want to both positive or negative, we can just draw a line through here, draw the points there, and we're counting up. You get the picture. What does it say? Vectors. And then we could use this for vectors too.
Yeah, that's what.
Very good. What else did we say? So coordinates and vectors. So it is very versatile even for upper school.
For transformation too.
I didn't hear that.
For transformation also. When you show rotations and so on.
Very good. Yes, very good. You know, when I was in I think it was in the master's program. I was doing in the master's program. I lectured about a geoboard and some elastic bands, and asked us to do a reflection on it. Okay, and then another thing that somebody was saying, we could look at this because from here to here is a centimeter. So we could use it for length conversion, okay? Now, so really when we make these things, we can explore with them as much as we want in our classroom and make our lesson more interactive and more thinking rather than telling. You see all this I told you a while ago, you see some things that you discover on your own, and you see it makes you think, don't it? And you have to dig into your brain and think. So that's the only idea. Dig into grade 2. Alright, so let's move on. This is what I wanted to do. I wanted to write down this addition problem, and then I want to do it with your Pisgah. 75 plus 91. And your answers would represent the least amount of materials. So you can represent, let me explain that again. You're doing a nice addition problem. 75 is right. Let me give you another number. Sorry, 75 plus 98. 75 plus 98. Sorry about it. I'm taking this. Now, when I say that your answer should represent the least amount of materials, I really mean this. Just like when you had 22, you could represent that 3 ways, don't it? But when I say represent the least amount of material, you know that it's 2/10 and 1 and 2 units. So your answer, I want you to do this problem. I want to go have enough. Do we have enough? Yes, ma'am, because we did 2. Yes. Good. So you're going to do this problem, and your answer should represent the least amount of material, and you have to be able to rationalize why you did what you did. Okay? Are we clear, everybody? So the thing, let me go say this again. You're going to add 75 plus 98, and then your answer should represent the least amount of material, and then you're going to rationalize why you did what you did. Least amount of materials, just like how when there was a 22, as well as big. But when the 22 represent 3 different ways, but you have one way to use more material, so you want to use the least amount. The answer should be. But you must rationalize why you think about it. If it's mathematical for you to do it.
Explain why I end up with that. You can explain. So even these things, even though you explain additional relevance, people take out the thinking, you can get the students to explain. We're going to scale. Just go on the first 15 minutes and you don't need to do it. Look here. You're not, I don't want a solution on a paper. No, that's not what I asked for. You're not supposed to add it first on a paper. You're supposed to use this to come up with the answer. You guys cheating. You're all cheating.
And this is 90 minutes. No, but you got the answer. I don't know what that is. Oh! So now we're going to take these and these things you will switch them around.
Okay. No, you're new long. You're new long. You have to line up everything. Line up everything. Yes, that's one of the terms for it. You said that all of these guys.
Still working? Need some more time? Alright, so one of the reasons why I want you guys in groups is for even activity like this. You can bounce ideas, you can work together. So it's good for you to be at your sites working together. But you can WhatsApp each other, communicate, and WhatsApp each other to see what you're coming up with, okay?
So we're going to take out 10 pounds and shake it with us.
Good job.
This one is about a micrometer.
I know.
You know, so you're rude.
About a micrometer.
Micrometer it out. Put some physics in it. I know it does. It's like
Micrometer speed is
physics and all of the older surviving insane. What? Sometimes they could be bothered. I used to cover the bio drawing.
Are we still working or finished?
Chemistry, I was doing.
We still working? Sana, are you done? I'm not hearing you.
Yes.
All right. Sabina, do you want to start or Diane? Sabina?
I have 100 tile, 7 pins, and 3 units.
Give me 1 second. Let's go. Yes.
Okay, I use a 100, 7/10 bar and 3 units.
So you have what? Go again.
100 bar, 7, the long one. Hello? My here now.
So you're adding, so, all right, so I don't want to answer. I want to tell me how you got the answer.
Okay, I could go.
Okay, I mean 98 is almost 100, so I use the 100 bar. And there were 2 missing in the bottom.
Okay. And so what
2
is
extra in the bottom.
Mm-hmm.
So with the 2 extra in the bottom, I just added 3 units close to it to represent 5. And then I put the 7 long bars.
Uh-huh.
And that's how I represented mine.
All right, very good. Very interesting. Very. Did you hear that? So she, 100, she had her this, so she put 2 more of the units of this and exchanged it for one of the 100. Good? And
yeah.
Then her 7 long ones. It's fine. Then was her 7 long ones, and then she would have our 3. Should I give her 173? Good.
100 minus 2.
It doesn't matter because that's the thing that we want our students to do. We don't want to shut them in a box. Yes, that's the thing. We don't want to shut our children in a box. We wanted to see that 98 is really 100 minus 2. See, so the shortcut because this is too good. So you're building number skills there. You're understanding that. Good. All right, any other method? Very good. Good job. All right, anybody? Look here, I've seen what they did, and it's not so interesting. So you guys tell me what you did.
Well, since it was addition.
I'm just kidding. All right, Sabina, you ready?
Yeah. Since it was addition, I used the squares to represent each figure. So 75, I had 7 tens.
All right, so you have 7 of the longs.
And 5 units.
Okay.
And then for the 98.
All right. For the 98, you have the same?
Yes, 9 tens and 8 units.
So basically what you have, I look like the diagram I have there, don't right?
Right, correct.
So you have your
So the
55 and this would be a 98.
9 tens and 8 ones. So okay. So the instructions would be, they know that 10 ones will be replaced. You'll replace counted if you count in the units. When you reach 10 units, you're going to replace those 10 units with.
All right, good. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10. No. So it's going to give me one of the long. Agree?
Yes.
Good.
Correct.
So I'm now going to have only 3 units.
Right. And then we count. Every 10 long ones will be replaced with 100.
All right, so I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, and this makes 10. So this is going to give me
100 cards, yeah. You'll be replaced with 100 cards. So therefore, we'll have 100 card.
So I'm going to have 1, 2, 3, 4, 5, 6, 7. So
right.
17. And then I have
100, yeah.
Very good. Any other method?
Can I share mine?
Sure.
I mentally I added 5 and 8. I said that's 13. So therefore I took 3 of the units and 1 of the 10 bars to represent the 13. Then I said 9 and 7. That would give me 16. So I put 6 more of the 10 bars, and then I took one of the 100 cards to represent the 1.
Okay, very good. Very good. Good job. And what did you guys do?
Well, one of our ideas was stolen.
One of your ideas was stolen. Give me the other idea.
It was exactly like that.
All right.
The grade 2 one.
All right. So this is a traditional way of doing it. Understanding that you're renaming as you go along. But one of the main things we want to walk away with is that, guess what? Our students, we don't have to shut them in a box. If I'm adding, I can manipulate numbers in my mind, and that is very, very important. So if I'm in the supermarket and I'm adding 98 and 75, all right, 98 is close to 100, so I can put 2 more on it. That will give me 100. How much more leaves? 73, so it would be 173. You get the idea? So it is about mental rigor also, okay? Good job, I'm proud of you. Clap yourself.
Grade 2.
Clap yourselves, man. Good job, those were very interesting. All right, so the next activity I'm going to give you to do is to do this. 200 subtract 1, 5, 8. And you're going to use your Dean's block to do it, and then you're going to, yes, and then you're going to tell me how you got your answer.
I'm hurt. This is mine. She said this is mine. I'm going to burn to it.
I keep checking my phone because we're supposed to be communicating via WhatsApp also in front of the class. Everybody wants to say. I told her yes. Yeah, but I gave her the number, but I wasn't supposed to from my understanding because one of the students are supposed to be. That's it. That's what you're talking for. Yes, that's what you're talking for.
And if you can't come out, I mean, what are the consequences if you just really can't make it? No, I mean, some persons will say that if you're absent 30% of the time, I mean, that was.
But for my course, the truth is, if you're absent on the assignment today, to do properly in assignment course. So if I'm looking at a relational Monday, you're not here, chances are your friends will extend holiday, they're going to look very honest. So look at the relational Monday.
Right.
Yeah.
And there is
so if you don't properly understand the relational Monday and how, and let's say we decide performance tasks and output things, but you need help to do that. You know what I'm making? Yeah. You definitely need to be in class to do that. I'm not going to give you anything that you can feel when you're in class and do it. Go on your own. What's the purpose there? And then when you look at the algorithm, well, from the algorithm you can start understanding and do it on your own. But even a lesson, we have to be a lesson plan. I want a lesson plan in a particular way. So you have to be in class to learn it. Okay.
Again, saying that use the other.
I don't think.
It's not like I have anything against the rules, but I'm saying if somebody is like.
No, but I'm sure that if you're very sick, I'm sure. Yeah, but I think that's what the problem is. Straight up. We don't want to be like no return class. Understand?
And also, I think another problem is that they made this program for specifically teachers who
For teachers who are, on summer break.
Yeah, that's what I think.
Okay,
And it just makes me wonder because I'm saying, wow, interesting. They're making these better teachers, however, better maths teacher, they have math specialists, stuff done by the Ministry of Education with curriculum and so on. I'm like, interesting. These people are supposed to just come. They don't have any kind of foundation in education. So I'm saying you make this for teachers only. It's a nice way of looking at it.
I think,
no, but Miss, I had to ask the question, and the person I asked actually was like, I could not believe the person was like.
University should be part of the society.
I'm not debating this with you. It's fine.
Miss, I'll use the course of curling on the weekends and catch what I missed, but I tried my best to share.
I understand that your hands are tied.
Yes,
I know your hands are tied.
You have a chore.
Go, let me go. Get back quick.
Can you be quiet and do it?
And since we need to break this up and take away so having a great science and because they have ones, they have 8 ones to take.
They're talking about math teachers and they're talking about and the funny part questions they're crazy and that's a mindset that I'm thinking that are you guys know Singapore and places like that they can't even go into the classroom without a master's degree. I'm like seriously, Jamaica consistently compares themselves to countries like Australia, New Zealand, whenever they're doing researches, and guess what? They're like, I don't know the education system here. I'm like, you got some dumps for leaders.
Maybe you should do strategy.
Oh, me? If I have politics, what are they doing lately? I'm going to tell them when I get right now.
Okay, there we go. We've got 200. You know, 200. And we're going to take away
part-time people at work.
Yeah, administrative workers. We're going to take away 100. 200, that's what 200. We're going to take away
Thank you for
101. And then we're going to take away 2, 2, 8. How much do we have left in?
I don't know. 42 from mental
There we go.
You have a point there. No, my experience threw me off. It threw me so off. It just, you know, I have a lecture friend, I have a class.
If the other students are going to be
Also, my question, Rosa, complete the work? Alright, so starting with you guys.
Politics alone, it's not worth your brain space.
That's what happened.
Alright, are we finished, guys, online? Everybody? I'm not hearing you.
Yes, we're ready.
Alright?
Yeah.
Let's start with you with the addition. I'm starting with Mona with the subtraction, okay? Alright, Mona, your turn. Come and demonstrate. Quickly, somebody quickly.
Mona needs to demonstrate?
Yes, they went from now to me, then it's about to me, then it's you. Come there now.
You're meant
to go in.
They want to stage. They need to be able to.
Can you be quiet?
Okay, so you have a 200. So you know for the 200 you have your big blocks, right? Right, Ingrid?
Can you all see what has been done on the board?
So you have two of those.
Good.
Right? And then you're gonna break this down. So you're gonna have one of this big block. Can I just write 10 of those? Or draw 2 of those? Okay. Ingrid, you're gonna come down. Oh boy.
You're becoming a better teacher, Dave. This doesn't even look neat.
Once more. So you notice we have here, same thing, big block. Now, what are we going to minus here? Units. Units, I'm actually doing it. So you have this in 200. Now this is 100, and of course you have 10 longs. 10, right. Now you're trying to minus 158. What do? You're going to go ahead and you're going to take away, of course, this big block.
Yes.
So when you remove this big block,
so put an X in it.
It's no longer here. Wait.
It's a different color here.
You're going to get rid of that. Right? Now, you have 5 longs to get rid of. So how do you do that? 1, 2, 3, 4, 5. Get rid of those. Now you have 8. Well, you need some units, right? So, as in regards to 8, 1, 2, 3, 4. What am I saying?
10.
Right, yeah. So, 1, 2, 3, 4, replacing, because, right, and then, wait a second. Am I counting properly? 4, 6, 8, 10. Right. Now, you have an 8. It's subtraction. You're getting rid of 8 of the units. 1, 2, 3, 4, 5, 6, 7, 8. You get rid of those. What's the answer that you get? You count. Longs, 1, 2, 3, 4. Units, 1, 2. So you have 4 longs and you have 2 units.
So 4 longs is 40.
And of course, you know longs, that's blocks of 10 units, blocks of 1, so that's 40 plus 2 units. Answer, 42.
Good job. All right. Something different? All right. Anybody else came up with anything different from that?
You can use your hundreds. You have 6 of them to start with. So therefore, and you cut up 2, so you have 3 more. You have whole ones. So you put down 2 whole 100 flat, and then you take the third one, cover the whole 100.
The third one.
Then you have your 5 tens and 8 small units. You cover the second one you already laid out. And by just glancing at it, you see the answer is 42.
Very good. Did you hear that? You have your 200, so you can just cover it. So I need to cover the 100, and I need to cover the 5 out of this and the 8. So what is left is going to be my answer. You get it? You look like Are you hearing that? So I use something else, and I use another one, and I cover the 100, and I cover these. So it would be nice if we have different colors,
right? Like shading out.
Or you could just turn it over.
Yeah.
So when you look, what is left would have been your answer. Good job. Very, very good. Good job. Good. So the next thing you're going to do is 14 times 6. That's the next thing you're going to do. 14 times 6.
No, you know, and in my research, people who love math, they actually develop their brain. It's just that their brain, their brain. John Nash, schizophrenia.
Anything wrong with that?
They were watching movie. You know what? Yes, you know what? Well, he lived until he was 18. The man was seen W. The Beautiful Mind movie had me though. I just want to watch it and I was like, oh God, it's nice. Like, all right.
I think it's hard to understand what you're thinking, to just get
no, I did. It's at the end of the movie. I was like,
yeah,
hey,
okay.
something's going on here.
Yes. But you know, this girl,
he's like, so small. What's going on here? And then I realized he's not going to plan on him showing the thing in the bin. And then the girl.
But you know, the little girl and the man. But what he used was reasoning to get him to realize that he reasoned that the little girl, even over here, this girl was getting the big one. She was the age here.
She's still small. Like, yeah. So when I think the doctor and the psychiatrist asked him, are you still seeing those people? Or no, the guy who he was always fighting with. I used to see those persons he looked. He's like, yes. So what do you do? But he just ignores them. Yeah. It's a
and even and that was very smart because even the fact that he was, let me say crazy, and he's thinking logical to realize this can't be real because this girl is not aged. She's even 20 years later, she's still the same.
That's what I was saying. I'm not stupid. Because you went and saw her.
It's a good movie.
Yeah, I loved it.
It's a really beautiful night.
It's a beautiful night. It's really a beautiful night. And what you're saying, he's getting my attention. You know what I'm saying? And he was writing on his book and stuff. And when he did that thing on the grass with the infinity time. That's a brother, I think, says people should use 10% of their brains, but when they like math, they use the more.
All right, are we here yet? So you guys are starting first this time around because Mona started first earlier, so we're rotating. All right, so where's Tasha? Oh, I'm not seeing you, so I'm just checking. Who wants to go?
I'm right here. I'm right here.
Okay, who wants to go first? Hello. So you're wrong.
go.
All right, go ahead. Sorry.
I said 6 times 4 is 24, so I took 4 units and 2 of the 10 bars. And then I said 6.
1 second. Okay, can I start again?
I said 6 times 4 is 24, so I took 4 units and 2 of the 10 bars. Then I said 6 times 1 is 6, so I took 6 of the 10 bars again, and I added to that. So I ended up with 8 bars of 10 and 4 units.
But what if I don't know my multiplication? I can't multiply none at all. So I mean, so in my mind, I kind of cheat on that one, you know, because you could multiply.
Oh, you.
Yes, man, you kind of cheat on that one. So you cheat on that one. Right. You're not wrong, but it will take a higher level of thinking.
Level of thinking. Yeah.
Okay, but I can try.
All right, go.
What we would have done since you said, hello?
I'm listening.
Oh, okay. Since you said 14 times 6, so we're basically looking at 6 groups of 14.
All right.
Right?
Yes.
So that's 1 bar, 1 10 bar, and 4 singles.
Yeah.
But then you're writing it on the board was a bit tedious, so you have to do it 6 times.
Yeah, it's fine. And then
Yeah, so you do that 6 times.
tired. So, you know, when it's tired, you don't concentrate and stay on the same level, you know, right? Yeah. It's like sleeping.
So
you
would observe that you have 4 10 bars and you have 4 24 singles.
All right. So it's going to give you so the 24. So each 1, 2, 3, 4, 5, 6, 7, 10.
Oh, 24, sorry. Yeah, 24. Right.
Go along, right?
Yeah.
Right. This.
Yeah, 6.
And this will give you another long, okay? So in all, you know,
yeah, 8.
3, 4, 5, 6, 7, 8 longs.
And 4 singles.
You know what I realize? It's really the units that you have to manipulate today. A lot of manipulating with.
Yes, the units. Yeah. So that's one way, and the other method.
Growing.
Any other method?
What is it the 14 group?
Yeah.
I want to go home tonight.
But what about breaking this? Because it's 10 plus 14 times 6. Can we do that?
We can break the 10, say have 1 10 and then 4.
6 groups of 10 and 6 groups
of 4.
Exactly.
So you can have a 6 here, so you represent using 6 of the 10. So let's give you a 6 by 10.
Are you agreeing with that? So you use the longs. And you make a rectangle. Are you following that, everybody? Because this is the same thing as multiplying 14 times 6. Wouldn't you say that? Mm-hmm. It's the same thing.
Yeah. This grade 2 wouldn't know to divide that. That's what I'm
No, it's not. It doesn't have to be grade 2, depending on what level. And look here, if you teach them properly, trust me, to break numbers and manipulate numbers, because the idea of using these methods for them to become a proper number skills. So they would have, if you teach them properly, they would have different mindset, because look how much thinking you have to do this. If you're extending a child's mind, you might be surprised as to what you can do. Alright. And then you can do what? Then you have put up set of the 24 units. Let me show you the diagram. I can't remember. There's 6 along, because here's a 6, and there's 4 across. Okay? Let me put it down for you to see. So see there. Say they're 10 by 6. So it's like a 6 long. See them here? Are you following that? And then this is 1, 2, 3, 4, 5, 6. But you know, you say it's just setting out. So and then when you count everything, this video 24 years plus 6. When you count everything, you get the total amount. Clear? All right. I'm just going to go down. I'm going to have a camera to work on. Good. 13 times. I so you're going to do 13 times 16. Let me read teaching us our multiplication times 16. I'm just going to think. I'm not 13 times 16. Somebody else do this. And I do division. We did 16.
Is it 13 times 16?
Yes, 13 times 16. And then we're going to do a division. And I don't think I will catch up on decimals tomorrow and percentage and all of those things. Remember that? Next. Oh, Lord. I won't be here next week. Celebrate. Oh, they're making it right nice right now. Good job. Say that to Bob. And this is actually, I'm going to show you, this is actually, you know, when you're doing like x plus 2 times x plus 3 is the same concept. It's the same. So this is like 10, if you do your box, the other 10 you say 3, you have a 10, you're 16. It's the same thing, you multiply, like you have x plus 2, you can expand it to x times x plus 3. X times x, you know, the x squaring 1. You follow what I'm saying?
Yeah. So it's like, so 100 bucks is helpful.
So really what you do, you know, when you multiply x by 2 by x by 3, you're forming a rectangle. So, so even these little concepts that you use, when you get to algebra, it concretizes it.
Generalize. Generalize just gets it.
What this is turn over. So you get what just write them down. Write them down. I'm not joking. I need to see a comedy in there.
See, it's not a give them the lyrics.
No, but I mean, like diamond. I like diamond. It looks like diamond.
All right, are we finished now? Still working, ladies? I'm not hearing you.
Yes, we're still out.
Still working? No, we have to finish up today. Division next, because I will be here. So we do the decimals, percentage, we do the algebra task, we do the fraction pieces, we do the tangram, we do the geoboard. You have to learn to do all those things. And then you're going to teach, so I need just to leave at least one clear class of teaching. And this is the easiest one. This is the easiest one. So even like yes, they're very good. So even the fraction pieces, can you teach high chart, high graph,
Okay.
Your solution, if you're doing an array, your solution should look like this. Are we seeing? If you're doing an array, your solution should look something like this. All right? Now, I was saying to somebody that when we're watching, are we listening? When we're looking at what we call removing brackets, for example, if we have x plus 2 times x plus 3, it's the same concept. So you'll have your x. So for example, let me pull this up. But do you know that I've given students so this is it. It's the same, as I was explaining, it's the same idea. So when you make the things with the algebra tiles, you'll have your x squared, you will have x squared, your 2x of the x's, you'll have your 3 to 6, and you'll have your 3x. X is 5, 3 to 5. But yes, can get it's going to form a rectangle, so either way. So it's basically building a rectangle. You can have it, and you can depend on what stage you want to put it. You can put the x plus 3 here, or down here, so you match it with the algebra tile. But as I get here, you'll see. But really, what it does is form a rectangle. So it's the same concept here. So if, for some students, you don't have to do this to show them it's x times x, and this times that, and that times that. That's going to confuse them. But if they get the whole idea of let's say 10 plus 6 and 10 plus 3. If they're multiplying like this, when they get here, it's the same thing. It's the same idea. Are we clear, everybody?
You can name those stuff too, like that one that you did. We're told it's the bird beak, so nobody forgot it.
This?
Yeah, the bird beak. So nobody forgot it. So our
I
teacher
didn't
told
know
us
that.
the bird peak, the bird peak, the bird. So nobody forgot. What does that mean? Yeah, she did it the other way though. The one, and then yeah, she told us.
So,
You see what it shapes like?
I don't want to try to, I think I do this in my class because some students, especially the weaker ones, they get confused with this. I don't know why. So if I do this, x over plus 2 and x over plus 3, you know it's x times this 2x, x times x squared. This time this gives me 6, this time this gives me 3x. And all we do is just a matter of adding. X squared plus 5x plus 6.
And you made another column.
Yes, so it's kind of, are we clear, everybody? Everybody clear? And are we understanding how to translate this to this? Everybody? Are we understanding how to translate this to this? Good for algebra. So I'm just saying, these little things that we do, it makes the life a whole lot easier when we get to grade 10 and 11 and we're doing all of these things, okay? So they can quickly, because they're accustomed to this, they quickly translate to this. They can quickly translate now. Yeah. All right, so we have just a division question to do. Then we're going to do some housekeeping because I won't be here. Yes, Dana, it's figurative. I won't be here next week. Your assignment sheet is out and you're supposed to be working on your first assignment, which is due at the end of week 2. It's just an essay. When you come next week, I will go through the assignment 2. I'll be teaching you the assignment 2. I'll stop with these manipulative and going through the assignment 2 for you so you can do it properly.
You said be next week, not next week.
The following, the week after. So I won't be here next week because I already have some things planned, some training sessions planned. So, but I will be here the week after that one. So you have me 3 times. So 2 of the class, I'll go through, 2 of those classes I'll go through and look at the assignment, how we do rubrics and how we do performance tasks, how we plan a differentiated lesson. So that relational model that you have there, we'll go through that next week. We'll pick up with all right, so I'll probably pick up with our Dean's blog in terms of decimals. Just quickly go through decimals and fraction. Well, this decimals and percentage, but we really need to start getting into algebra tiles and the fraction pieces. So we'll see, and we really don't have a lot of time. As you can see, time is running away with us. Okay?
So our first assignment, we email it to you on Friday.
You don't email me your assignment. You bring your assignment. So you can bring it there. So first, so for those of you who are not in Jamaica, you have until Tuesday evening, not next week, but the following Tuesday evening, to email the assignment to me. Are we clear? Good. And please don't leave off your ID numbers from your assignment. The course, the code for the course, those are essential information that must be on your assignment. Are we clear? If you leave off your ID number, your assignment will not be marked because I don't know who this person is. So even if you don't write your name, the ID number must be on your assignment. Are we clear? Yes. That applies for. All right. All right. All right. Right. Now I wanted you to do a division. So okay, the next thing I'm wondering if I need to stop now also because you have a teaching session to do. Providing that I will not be here next week, should I start to assign topics, like allow you to choose a topic so you can start to kind of think it through and look at it for what you're going to be doing for your micro teaching activity? Would that be something that you would want to do? Okay, that would be good. So, all right. So what I'm going to do, I'm going to allow you to do a quick division while I bring up that page on the different topics, and then I can start to determine you what you want to do. 69 divided by 21. All right, quickly do that. Let me bring up your back page. Because week 4, I can't do much teaching in week 4. Until the 2 before, because I have one class is just out. But if I don't get to teach on the same
Unless I saw something here. Yeah, it was fine. That's assignment 3. Wait, the micro teaching. That's a part of 4. The assignment 4. That's week 4. Beginning week 4.
Yeah.
Assignment 4A.
So what if the assignment will have to do, like, because you have 4 pieces, I can't do that. There's no way for them to do the first, and assignment the first, do the first week. That's just not practical, because they're settling down. So what if there's something will be due, like, a week after access?
Regarding the micro teaching, of course, it's a presentation. Right?
It's just
so you teach a lesson.
yeah, but 15 minutes. But by that, I'm sure you know what to do. I won't assess you on something that you don't.
And the lesson plan, of course, we want to be, of course, it's a lesson plan of what you're going to teach.
Yeah, but I'll go through all of that today now, so don't get very anxious.
Yes, that's me. I write things down, I plan, I don't know why I do these things.
Don't get very anxious. But go through it, because I wanted to assess you on something you're not equipped. So, even though I know some of your teaching, I would still go, because what I require for us is probably a little bit more detailed than what you have to do. Right?
Meaning that I am not the teacher.
So,
oh, this is just one thing I was looking at. With the assessment sheet, you had the grades 20, 30, and then 20, 30, 20, that was 70. And 10% criteria for assessing the lesson and 10% criteria for assessing. Yeah, right. But so the course outline really on this the course outline, the written assessment, first one 15%, then next one 25%, micro teaching 35%.
Yes, there are some changes.
Okay, so those just the outline doesn't matter then. Just
no, it's just yeah.
Okay.
So the course outline is really for kind of
the course outline is read it, like the objective and stuff. Don't look at those. Those are like probably that.
Because what happened is that initially, because you know how the courses have to be revised all the time. So sometimes when the course is being revised, it's not that we revise the content, we revise the assessment method. So the course outline that was sent to me is probably an older.
Yeah, that's what I was thinking. It was older because the course assessment grades, I mean, the percent were different from this. And but the objectives and stuff, but the values are new.
Alright, so who should go? Mona or who went the last time? Felusha?
Yeah.
I'm sorry. Alright, so did we get this? So I'm gonna go through now. We're gonna insert your names. You're gonna choose, look at the topic that you want to teach, and allow you to choose a topic so that we can do a good job. And remember, as I explained to the Mona students, is that this course you're focusing on developing concepts. So the concepts for grade 7, 8, and 9. So the lesson that you will teach is for grade 7, 8, and 9. The courses I will teach you in summer 2, you're focused on grades 10 to 13. So it will be looking at how do we, after the students have developed this concept now, how do you build on these concepts to teach things that are a little bit more abstract, okay? So remember that this course is mainly focused on the grades 7 to 9, and then the next course is now on grades 10 to 13. Is it clear? And for those of you who only teach upper school, you'll see just how these little things can help you to teach or provide, like, for example, I was explaining to Alisa, that even some of these activities that you do, you might think that it's not advanced enough for upper school, but you can do it as an introductory activity, just to kind of teach them a skill or something. It will be that's a good way to use it if you only teach upper school. Alright, so quickly tell me, what time is it? Quickly tell me. 7. Yes, so I'm sorry for running a bit late. Quickly tell me, somebody from not Jamaica, tell me how did you do, what is it that I gave you again? 69 divided by 21. 69 divided by 21. How did you do that? Anybody, quickly?
I had 6 groups of 10 bars and 9 units.
Mm-hmm. Yes.
And then I broke it down into groups of 21. So it ended up with 2 bars of 10 units and 1 unit on its own. 3 times.
Okay. So it was 69 divided by 21.
I had 6 bars of 10 units and 9 single units.
Mm-hmm.
And then I broke it down I started dividing it into 2 bars of 10 units and 1 unit.
Yeah.
So I ended up with 3 of those.
Yes.
And then I was left with 6 units on its own.
Remainder is 6?
Yes.
Very good. Good job.
Thank you.
Alright, so quickly I want you all to focus a little bit on the screen here, and these are the topics. So you're going to quickly tell me. I'll type in your name. Oh, then I put it on the computer and type in the name for the different topic. So probably since you're going to type, you can choose a topic first. No, it's on the computer, so I will just save it. I'll just save it on the computer. I think I have purchased. Yeah. So these are the topics. So if you tell me which one you feel more comfortable with, then see. So just type in the name where you want.
I can't make this out. It's not clear. It's too small.
You're not seeing it?
Can't see it.
No.
The font is too small.
Oh, it's too small.
Beside the topic, the names beside the topic?
Yes, that's it. All right, so we have place value, division by fraction, area, volume, percentage, ratio, profit and loss, Compound interest, purchase angles, pie chart, congruent triangles, trigonometric ratio, vectors, translation, rotation, enlargement, frequency distribution, bar chart, histogram, polygons, quadrilateral mean, median, variation, direct and inverse, subject of the formula probability, coordinates on the Cartesian plane, algebraic expression, equation, solving linear equation, solving inequality. So,
I would like to do mean, please.
Mean? So
Yes, please.
that is Jeffer.
Yes.
Just you can just write the first name, it's fine.
Can you email the topics? Cause
you want me to email the topics?
Yeah, and then probably on WhatsApp or something, I could let you know what I want to do because.
Okay, so I don't have a. Let's take a picture on that and then send it on WhatsApp immediately.
Because by the time you say the third one, I forget those you said before. So I don't know.
We don't have purchase.
All right, so I'll email it. I'll just save this and email it to you and then tell me which one you want, okay? All right, Sabina, can you remember anything that you wanted to do or do you want it to be emailed to you also? Sabina, are you hearing me? Okay. No, I'm trying to figure if that's the case. Okay, Tasha? I'm not hearing anybody. I mean, I just email, but you guys can put in what. Tasha, are you hearing me?
Yes, I am.
Okay, have you decided on a topic or do you want me to email you what I have here?
I would like to do bar graph.
A bar graph, that's Tasha.
Tasha Zero.
Bar graph. Do you have bar graph on it? All right. So Diana?
Solving equations, linear equations.
All right, and then Diana is gonna be solving. Linear equation. Diana. We have that. Zana, have you decided?
Algebraic expressions.
What was that? Algebraic expressions.
Algebraic expressions.
Okay, and that's up to grade 9.
You hear me?
That's fine, you're fine, Zana. Yes, Zana. And Sabina, did you tell me what you wanted to do? No? Sabina, are you there?
Yeah, I can see the board clearly.
I'm not hearing you, honey. I'm not hearing you, Sabina.
Yes, I said I cannot see the board clearly, but I think you said compound interest, so I guess I could do compound interest.
All right, Sabina is doing compound interest. Is that it? Carter, have you decided? All right, so Do I have everybody now? All right. So just think about that. Just think it through. If you're not ready to choose, that's fine also. So I guess I'll see you. Yes, you can change if the slot is empty. You can change if you wish. Yeah. Once the slot is empty, you can change if you wish. All right? All right, guys. See you after next. Remember, you have to work on your assignment. So I won't be here because I have some things to do. But I'll see you week after next. Okay? So enjoy your week and your week.
You too.
Have a good one. All right.
Thank you. Good night.
Bye. Thank you.
Bye. Bye-bye.
Bye.
I chose simple interest. You chose simple interest?